Hello, everybody. Welcome. This is the second workshop for the Commercial Harborcraft Technical Working Group. We're just going to give folks a few minutes here to get into the webinar before we get started. Welcome, everybody. This is the second workshop for CARB's Commercial Harborcraft Technical Working Group. We're just going to give folks a minute or two to get into the webinar before we get started with the day's agenda. And Leticia, if you want to, we can start um, alternating translation.
Sure.
Great. All right, welcome everybody. This is the second workshop for CARB's Commercial Harborcraft Technical Working Group.
Bienvenidos a todos. Este es la junta que vamos a tener el día de hoy de embarcación de puerto, grupo técnico de trabajo.
We're going to get started here in just a minute or two. I'm just giving time for everyone to join the webinar.
Y vamos a comenzar como en 1 minuto a 2 minutos. Solamente estoy dando oportunidad para que los demás puedan acceder a la junta.
Okay, I think at this point we can go ahead and get started.
Creo que en este punto ya podemos a comenzar.
Welcome, everybody who has joined. This is the second workshop for CARB's Commercial Harborcraft Technical Working Group.
Buenas tardes a todos. Este es el segundo taller de la junta de la embarcación de puerto comerciante, que es un grupo que trabaja acerca de las cosas técnicas.
Next slide, please.
A la siguiente diapositiva, por favor.
Okay, so we do have live interpretation for today's meeting in Spanish.
Y sí tenemos interpretación el día de hoy en vivo en español.
And we're going to go over the instructions here on how to join.
Va-
Yeah, go ahead, Leticia. Thanks.
Sorry. Vamos a pasar sobre las instrucciones a cómo juntarse en español.
So the first step is once I launch the interpretation function, you're going to see in your webinar controls at the bottom of the screen a globe that says interpretation.
En cuanto ya vayamos a subir la presentación, usted va a poder mirar abajo de su pantalla o en la parte de la herramienta un icono como en forma de un globo donde usted va a poder escoger qué lenguaje usted quiere escucharlo en.
Then you're going to click the language that you would like to hear, and the options for today are English and Spanish.
Y ya después usted puede escoger sea el inglés o el español que usted escoja escuchar la junta en.
So you'll need to select English or Spanish for both channels. So if you'd like to listen in English today, you got to click the globe, select English, and same if you'd like to listen in Spanish.
Y si usted quiere escoger escuchar la junta en los dos idiomas, tiene que escoger los dos, el lenguaje inglés y el español, para poder escuchar de los dos módulos.
And then all of us as well will need to click mute original audio.
Y también todos los demás de nosotros vamos a tener que escoger enmudar el audio original.
All right, so at this point, I'm going to go ahead and launch the interpretation function, and you'll see that globe appear at the bottom of your screen.
Y ya a este punto ya voy a comenzar a subir la plataforma para poder escucharlo en inglés o en español, y usted va a escoger con el icono del glóbulo cuando lo vea abajo de su pantalla.
Just one second. Okay, Okay, so the language interpretation function has started, so we can all go ahead and find those globes at the bottom of our screens. If you're hearing me now, you're in the English channel, so go ahead and select English. If you'd like to listen in Spanish, you can select Spanish. And then please also select mute original audio. Great. All right, next slide, please. Okay, so at this point, I'm going to hand it over to Bonnie Soriano. She's the Chief of the Freight Activity Branch with CARB for opening comments.
Hi, everyone. I'm Bonnie Soriano. I'm the Chief of the Freight Activity Branch, and I'd like to welcome all of you to the second Technical Working Group meeting for the Commercial Hovercraft regulation. At this meeting, we have staff from the program team, and we also have staff from CARB's enforcement and legal areas joining us. For some high-level background, some of this is a repeat from our first working group, but I wanted to provide some background for those of you that are new to these meetings. The technical working group came about from direction from the CARB board during the rulemaking process. In Resolution 22-6, which approved the amendments to the regulation, and that was in 2022, CARB's board directed staff to form a technical working group. And the purpose of this group is to keep the CARB board updated on two specific topics. One is to assess the commercial availability of lower emitting combustion engines. And the second is zero emission technology, and that's for all categories of hovercraft. And then report back to the board by the end of this year, 2024, and then every 2 years after that through 2032. So this will be an ongoing process. The technical working group is public, and we welcome all affected stakeholders, environmental and community-based organizations, technology developers, engines and aftertreatment manufacturers, academic institutions, government agencies, and all members of the public. As I said, this is the second of 3 meetings that will help inform our report to the board that's due at the end of this year. For those of you that attended meeting number 1, the focus of that first meeting was more foundational. We had overviews of the regulation, common technologies used to meet the requirements, and impacts to the affected communities. This meeting is focused on technology advancement, including both the advancement and availability of the cleanest certified marine engines and the progress of zero-emission technologies for the marine sector. To assist this whole process, we have contracted with Cal State University Sacramento to facilitate the meetings, and a big shout out to Sac State. It's been a great help to us. And also I wanted to give a big thank you to the interpretation services. We have also contracted with the University of California at Irvine to perform a technical assessment. And today they will be discussing that technical assessment, and then we'll have a report that's due to us later this year, which will be part of our report to the board. We are also tapping into the expertise of stakeholders via panels, where the stakeholders can directly speak about their experiences and expertise. And I want to thank all of you in advance that are participating in these panels, both at the first meeting, the second meeting, and the third meeting. We have panels. And for today's meeting, we are very excited to include a panel that will provide information on real zero-emission marine projects that are being built now. So we're very excited about that. I would also like to add some clarification of what these meetings are not intended to include. They are not structured to answer case-by-case implementation questions. If we get those questions, they'll be held to the end if there's time, or we'll look at them to determine if follow-up is needed. This is not a formal rulemaking process, but it is a process to inform and update the board as the board directed us to do. And as we begin this meeting, we would like to recognize the wealth of perspectives and expertise that this group brings to the table. We would also like to acknowledge the community groups for their work in advocating and articulating the need for public health benefits, the technology providers in advancing the technology, and industry's efforts and financial commitments to comply. All of these combine to improve public health and reduce environmental impacts from the sector. And with that, I will turn the meeting back to the facilitator.
Bonnie. All right, next slide. Okay, so quick review of today's agenda. I'm going to finish up with some opening remarks. We have our first session today, which is on technological advancements, combustion technology assessment. We'll have a Q&A for 10 minutes, and we're also going to be launching a poll to get to know you better, who's in the room with us today. Then we're going to have a 10-minute break. We'll continue with session 2, which is focused on zero-emission technology assessment. We'll have a Q&A for 15 minutes, and then afterwards we'll have another 5-minute break. And then we're going to conclude with a panel discussion on zero-emission and advanced technology, ZEAT. We'll have a Q&A for 20 minutes, and then we'll conclude. Next slide, please. All right, so I don't want to be duplicative. Bonnie shared a lot of great information, so I'm going to move through this a little bit more quickly in the interest of time. My name is Julia Cernansky. I'm part of the facilitation team along with my colleague Dave Sepos, and our role is really to support CARB in the coordination and development of these workshops. Next slide, please. A little review of the technical working group's composition and some of the guidelines for participation. As Bonnie shared, the workshops are open to the public and all participants are invited to attend via CARB's Commercial Harborcraft Government Delivery Notification System. And the goal is really to provide a cross-section of presentations and panels invited by CARB and directly representing those who are directly impacted by commercial harborcraft regulations and or affected by commercial harborcraft and the associated combustion emissions. Some guidelines for today. We just ask that everybody maintain this space as a respectful space where everybody is heard, that one person speak at a time, that we stay focused on the agenda topics. And as Bonnie mentioned, we stay focused on the topics of the presentations. Case-by-case questions will be answered by CARB outside of this meeting. And I'm going to put an email in the chat right now where you are also invited to send any additional questions or comments that you may have. We do have the Q&A open today to help facilitate taking questions. So you're able to offer a written question in the Q&A. We just ask again that that stays focused on the agenda topics and not questions related to individual case-by-case situations. Next slide, please. Okay, so the objectives for this workshop, workshop 2, are to provide an assessment of cleaner combustion and zero-emission technologies for harborcraft, and that includes Tier 4 engines, exhaust aftertreatment, alternative fuels, and ZEAT projects. We're also hoping to obtain technical working group feedback from all of you on the technology presentations that will be provided by our colleagues at UC Irvine. And then we're also going to have a panelist discussion and ask for technical working group feedback on ZEAT project implementation. So a quick overview of the timeline of the technical working groups thus far. We had our first workshop on April 24th, and the recording is available on our website. I'll also drop the link in the chat to our website. This is the second workshop, and workshop 3 will be focused on best practices and expertise sharing, and that is scheduled for August of 2024, and we'll be sharing more details in the coming weeks. Next slide, please. Okay, great. So at this point, I'm going to hand it over to our colleagues with UCI, John Slope, Michael McKinnon, and Vincent McDonald.
All right, thank you, Julia. So I'll start
Vince,
off.
I can't hear you. So you might not have done the mute original audio step English channel.
How about now?
Perfect.
Okay. Thank you, Julia. We can go to the next slide. All right, so I'll start off and go over advancements on the combustion technologies. And I want to give credit to John Slope, who did a lot of the work putting material together here. He's on the call in the event there's questions that he can answer. And then Mike McKinnon will take over on the ZEAT technologies. So next slide. So what I'm going to cover here in the next 40 minutes or so, I just wanted to set up the regulatory perspective a bit, just to know kind of what we're shooting for, and then get into the advancements on what are called Tier 4 marine or marinized engines, along with current after-treatment strategies. I'll then give a bit of an overview of where we stand on technologies that are commercially available under Tier 4, and then finish up a bit with some perspective on alternative fuels. I also want to point out that Dr. Jeff Reed is also on the panel, and he has a lot of expertise in the area of alternative fuels. So if there's questions on that, he can also be available for discussion. So with that, yeah, I look forward to having a discussion with you all today and getting feedback. Next slide. So just to begin with, right, Tier 4, that's an emission standard that really the EPA created. This is something that's directed at both NOx and particulate matter. So NOx and PM, as we might typically call them. These apply to so-called Category 1 and 2 engines. So these are marine engines that are roughly 10,000 horsepower and below. It's not the very large engines, and typically, but not always, that there's what's called an after-treatment system that's involved, and I'll talk about that a little bit here in a slide coming up. But many of you may have heard of technologies like SCR, which is selective catalytic reduction, which is widely used for many combustion applications to reduce NOx levels. So this would be nitric oxide, or NO, and nitrogen dioxide, or NO2. One of the challenges we have in California with air quality is associated with particulate matter. So these are fine particles. And so one of the things, in order to kind of meet the air quality requirements that we have, is a special attention on PM. And so typically what's called a DPF, or a diesel particulate filter, is incorporated to help with the management of the particulate matter. The chart on the bottom there just gives you sort of a perspective on where the CARB standards sit relative to some of the other standards that are out there. So you, of course, have the EPA standard, which is nationwide. IMO is for European Union. EU is also putting forth what they call a stage 5 requirement, and you can kind of see the numbers there. But again, the after treatment goes after the NOx using SCR, and you can see the very low, relatively low PM numbers, particulate matter numbers, and to achieve those, typically a diesel particulate filter is going to be needed. The next slide just again reminds us of the various compliance dates. Admittedly, there's quite a bit of information, but depending on the type of craft or type of vessel that you have, and what sort of current engine technology you have, there's different dates that have been set for compliance, which are illustrated here. And this is applicable to both main and auxiliary engines. And you can see some of the earliest compliance dates are 2024, 2025. So basically these compliance dates are kind of upon us, if you will. And you'll see that there's examples of folks that have done adoption of technology in an effort to try to get into compliance. Next slide. So again, the regulatory perspective, this is, you know, from my perspective on this, that this is an example for on-road, and the trends are very similar for European Union, but what this is showing are the progression of the emission standards for NOx on the left and PM on the right as a function of year, right? And basically what this is showing is an evolution of 40 years of regulation, which results in technology innovation. And all of this, of course, has to be balanced from a cost perspective. Is it practical to implement? You know, is it reliable? Right. So it's a delicate balance, but the effectiveness is without doubt, right? I mean, orders of magnitude reduction in the air pollution has resulted as a result of this process. So each sector is different and it has different requirements, and of course the marine sector is no different in this regard, right? They have their own perspectives, own requirements, and so yeah, we're all working together, if you will, to try to improve the air quality. Okay, so next slide, I'll transition into the technologies associated with the Tier 4 engines, along with the aftertreatment. So next slide. So the of course, right, the first thing when these regulations started to be implemented, the first thing that combustion engineers did was try to figure out a way to solve this in the combustion system itself. And of course, the primary technology that we're talking about for marine applications are diesel engines. So we're talking about compression ignition. These engines typically have higher efficiency. They're very durable, very robust. They have high power, right? So the technology for diesel is well established and highly applicable for marine applications. The chart on the right is one that's a bit ubiquitous in the combustion science world, in that it more or less points out the areas where we have challenges with what's called soot formation here. So that's basically the particulate matter, PM. And then in the lower right corner, you see NOx, right? So in essence, right, from a combustion in the cylinder viewpoint, right, if we can steer the conditions towards areas where there's a simultaneous minimization of soot and NOx, we can actually cause a significant decrease in emissions of both of these. And essentially NOx, you can think of it simply as like, we want to operate at lower combustion temperatures. That's the best way to control NOx inside the engine. To control soot, we want to keep enough air in there to try to avoid what are called fuel-rich regions. Because soot's basically unprocessed fuel. And we don't want that for many reasons. So this general advanced combustion technology is broadly referred to as low temperature combustion, or LTC. And so there's a few bullet points there of like examples of strategies that have been implemented in order to keep the combustion process away from these islands of high soot or high NOx. And we get significant emissions reduction with that. But without a doubt, incorporating aftertreatment gives us another 10 to 100 times reduction in NOx and PM. So it's not surprising that to attain the lowest emissions levels, we want to incorporate advanced combustion technology, but also complement it with aftertreatment. So next slide is kind of gives an initial perspective on this, right? So almost all the current commercially available Tier 4 engines have a distinct after-treatment system. And it can be modular. Most of them, in fact, are. And the little diagram on the right gives an indication of this. So you have your basic engine sitting there to the lower left, and then we want to add on to that an after-treatment system. In this case, we're adding a selective catalytic reduction system, mainly to control the NOx. And as you can see, right, that's a module that's not an insignificant amount of volume, and it's basically attached here to the exhaust of the engine. The SCR system basically uses a very well-established technology that involves ammonia, which will react with NOx and convert it into molecular nitrogen and water with the aid of a catalyst. So hence the selective, right? We're focused on NOx. Catalytic, there's a catalyst, and we're doing that to reduce the NOx. So the little reaction is shown there. Where does this ammonia come from? Well, typically it's coming from decomposition of urea, and urea is usually contained in the form of what's called diesel exhaust fluid, or DEF. So now the SCR module is one component in a potential state-of-the-art after-treatment system. The next slide gives a feel for all of the potential components that you might have. And so there's a lot on here, but basically you see the engine block, and then after that comes the potential pieces that can be added on. And so coming out of the engine, we flow into what's shown as an optional diesel burner. There's what's called a DOC, so that's a diesel oxidation catalyst. The filter is the diesel particulate filter, right? And then from there, it goes down. We see a little blue spray of urea. So this is the diesel exhaust fluid. It's basically 1/3 urea, 2/3 water. That's sprayed in. It reacts on the SCR, or selective catalytic reduction unit, and then comes out the exhaust. You'll see there's a number of sensors to monitor NOx, to monitor pressure. All of these sensors are used to tell the engine control unit, right, if the after-treatment system is performing as desired. So this is just one example, and you can see the yellow kind of box or oval there gives an idea of what the reduction efficiency is for each of these species. So it's highly effective at taking the engine out, NOx and PM, and reducing it into innocuous exhaust. One thing on the diesel burner, right? So the diesel particulate filter, and again, this is something that's probably needed in order to attain the target PM levels that the Harborcraft regulation is targeting. The diesel particulate filter is literally that. It's a filter. It's physically collecting these particles. If that filter is hot enough, so about 550 degrees and up, right, the particles that are collected on there will basically oxidize and get eliminated. If the temperature of the filter is low enough, the particles will just be caught and eventually plug that filter. If the pressure drop gets high enough, you may end up with what's called an active regeneration, and this involves running a little bit of diesel fuel into the diesel burner to heat up that filter. So anyway, these are the considerations for the after-treatment system. Next slide. Where do we put the DPF? Well, this is another consideration in that some of the Tier 4 engines have the engine technology plus the SCR. if we want to do additional work on reducing particulate, the thought is to bring in a DPF. Well, what if we just put the DPF on the end of the SCR? Well, it's possible to do that, but the temperatures there are fairly low, and so there might be a need for more regeneration of that DPF. But logistically, it'd be nice to just add that on. Otherwise, the DPF in most systems that use DPF sit between the engine and the SCR. There's an example from Ford, their Power Stroke 6.7 engine. They do have the DPF after the SCR, so that can be done. We didn't find any maritime applications that had the DPF after the SCR. There's also active development of a single module system that basically adds the SCR component to the DPF. So this would be one module that would go where the SCR currently is, but it integrates the DPF and SCR functions. That's being developed now by, for example, Johnson Matthey, as shown there. Not ready for maritime yet, but an interesting development. Next slide, please. So these are some examples that some of the engine companies have developed as a modular add-on. This is one example from Mitsubishi, and you can kind of see the module there on the left image, and then on the right image you see a little cartoon that's got the engine, then two exhaust pipes coming out, and then this SCR module connected to that. So this is the way for this engine that Mitsubishi has implemented this. The next slide shows a similar example for Cummins. All right, there's their HH4000 SCR. This is their smallest SCR unit, right? But the idea is to take the engine that you would have on the right and otherwise add the SCR onto it, and that'll take care of your NOx, but maybe not good enough for the PM. So next slide. So another way to attack NOx emissions besides SCR is what's called exhaust gas recirculation, sometimes called flue gas recirculation. Again, this is something that was done early on to drive down NOx emissions in diesel engines. It's used commonly in many combustion processes, but the takeaway from this is you can get an order of magnitude NOx reduction if, rather than bringing pure air in, you bring in, say, 80% fresh air with 20% of the exhaust gas recirculated in and mixed in with that air. What's happening here? Well, essentially the exhaust gas is CO2, water. These are three body molecules, so they have high heat capacity. So they're able to basically reduce the combustion temperatures, which in turn reduces the formation rate of NOx. So this is another well-established strategy. And next slide. This shows an example, a company called Wabtec, which is basically a derivative out of General Electric's locomotive engine technology. They offer an engine now that does not use an SCR, doesn't use a selective catalytic reduction system, and thereby does not need the DEF liquid tank as well, right? So this is an interesting kind of recent development and an example where just EGR is used to attack the NOx. Next slide. Now, the trade-off, I guess, is kind of illustrated on the right, where we don't have DEF, we don't have an SCR system, but we do have to mix in the exhaust gas with the fresh air. We also want to tailor those temperatures, so now we have some heat exchange equipment that is involved, and so there's some complexity added there. But it's an alternative to SCR and diesel exhaust fluid. So next slide. So as far as other ideas for reducing the particulate, beyond what we've already talked about, a diesel particulate filter, there is the idea of what are called electrostatic precipitators. This technology evolved quite a bit during COVID, right, as a way to clean up building air. So why not try this for exhaust? And there's a number of manufacturers that are pursuing this, but it's effectively a sort of a surface area type device, which means the device is pretty large to be effective. And so again, the physical space these require can be quite large. The early systems, maybe we'll see it on ocean-going vessels. I'm not sure. The smaller units, they're not as effective as the larger units, as shown by the Fuji Electric example. And at that point, right, it's maybe 60% efficient, which is not sufficient to meet the 85% requirement. But this technology is evolving, so something to keep an eye on. Next slide. Okay, so what's commercially available for Tier 4 engines? Let's talk about that for a bit. Next slide. Okay, so this is sort of a timeline of what's available and in what size ranges over the last few years. And what you can see is there's not a huge number available, but there are engines available, and we are starting to see developments on the smaller side, right? So engines below 600 kilowatts are starting to become available. And there is kind of steady growth, from 2020 and onward. Next slide. So this shows as of March, and it's sorted by power output, all of the commercially available Tier 4 engines. So there's quite a few different manufacturers, different sizes. Typically, these are 4-stroke, more than 600 kilowatts, not using a diesel particulate filter yet, all right, but then they're typically using SCR for NOx cleanup. There are a number of exceptions. These include M&H Engineering, Baudouin, which is a French manufacturer, MAN, and then Wabtec, which I talked about before. So we do see some entries now in the sub 600 kilowatt, which didn't exist, 5 years ago. So I'll just highlight a little bit on some of these exceptions on the next few slides. So next slide. So this is an example of the M&H Engineering, right? So these are basically John Deere engines that have been marinized. The marinization was kind of implemented in 2023, and these are equipped with diesel particulate filters. So, and you can see you've got 130, 220, 300 kilowatt options available. So this is pretty new in the last 5 years or so. Next. This is the Baudouin. These engines are IMO 3, EPA 4, Stage 5 certified, also less than 600 kilowatts. They make auxiliary gensets, as shown on the left, and also propulsion engines on the right. You can kind of see most of the manufacturers are cognizant of, we've got to fit all this stuff into the engine compartment, so they want to be flexible on where they mount the different after treatment systems. These guys also offer larger engines, as is mentioned in the bottom note there. So next slide. These are the MAN engines. So these feature a diesel particulate filter. So we've got the full complement of diesel oxidation filter, DPF, and SCR in the after treatment system. And these engines can meet the in-use performance standards. You can see the different models that are available in the 12 cylinder configuration. So these are medium size, right? Kind of 700 to 1100 kilowatts, but these are commercially available. Next. So these are the Wabtec engines. So here we're using the EGR solely for NOx without any SCR. These particular engines are the larger category 2 type engines. But again, these are the ones that are currently available that can meet the NOx levels with EGR alone. So these are all available recently. Next. This is the EMD. So this one's a little interesting in that it's a 2-stroke, not 4-stroke engine. So there's some interesting considerations for that. Again, we've got, you know, V8, V12, V16, V20 engines, but they're all larger engines, category 2 engines. But again, they're tier 4 engines, but with a 2-stroke operation configuration. So you can see on the picture there, right? Again, the SCR and the DEF kind of sitting over the engine, sort of a typical configuration. All right, next. All right, so then these are just a few example California installations that have implemented some of these technologies. So we've got three examples here. There's probably more, but it's just these are 3 to highlight. So let's talk a little bit about each one of these. Next slide. So this is the PV Golden Gate, and so this is a pilot run vessel. It's basically a vessel that was replaced. The existing vessel with tier 2 technology was replaced with the new tier 4 engine technology. This is located at Pier 9 in San Francisco Bay. This is designed for high speeds, you know, basically moving pilots around. It's operating almost 24/7, so very you know, very effective with the typical diesel type engines. But now they're going with the lower emission technology. Next slide. So this shows kind of a comparison of the original vessel. So we increased the length a little bit, right? But the key thing was exchanging the tier 2 main engines for a set of tier 4 engines. So in this case, they're using the MAN 2862 low emission 438 engine. And it's interesting in that the design of this vessel was taking into account the fact that DPFs would be needed. So it's the engine compartment, everything was designed to accommodate the DPF. It hasn't been put in yet, but is ready to go. So this is, you know, looking ahead. With the redesign and reconfiguration, they were also able to incorporate an improved aluminum hull that gave a few knots of additional speed and also about a 10% increase in overall fuel efficiency. So it's a kind of a win-win, lower emissions and improved performance. Next. So bottom line is on emissions, at least, right? We've got a higher performing boat with a roughly 70% reduction in NOx compared to the tier 2 engines and 80% reduction in PM. So impressive emissions improvement, which is what we're after. Next. Okay, so this is the Water Emergency Transportation Authority. They're Gemini class high-speed ferries. And again, this is an example of a retrofit, basically changing the engine technology to tier 4 technology. Next slide. So this is the some of the details there. The new engines are a dual MAN tier 4 feed 28620 V12 engine. And so that switch was made, and then the performance in terms of emissions on the next slide. Basically more than 90% reduction in NOx and 80% reduction in PM. So again, impressive improvements in emissions. Next. So this is Alta June. It's a tugboat example. So it's an escort kind of ship assist tug. There's a picture shown there. Again, a repowering project. So next slide. This shows some of the details there, right? So originally built in 2008, and it had Tier 2 Cat engines. It was repowered in 2022 by Bay Ship and Yacht, and it's using now the Tier 4 Cat engines, and it's noted, yeah, there's some additional requirement for the SCR system. You can see the picture of the engine and the what they call a clean emission module. That's basically the SCR system, and then the dosing cabinet that's used to hold the DEF. Typically, the DEF that you need, it's like maybe 5% of the fuel itself, right? So it's not a huge amount. Next. So again, 70 and 80% reduction in NOx and PM. So, but same vocation, just cleaner engines. So next. Okay, then real quick on alternative fuels a bit. So, this chart nicely shows the just how darn good liquid petroleum fuels are. I mean, where you want to be on this chart, which shows volumetric energy density on the y-axis and gravimetric on the x-axis, you want to be at the top right. All right, you want to, right, that's where you want to be. And you can see diesel is right there. It's like just an amazing fuel, right? So there's a bunch of other fuels shown on here. And generally you're going to need more volume to accommodate it, right? Or you're not going to be able to put in as much, right? So it suggests reduced emission for the same fuel tank size. Some of these are gaseous. The next chart kind of is a more fair comparison, right? And there's energy requirement associated with compression and storage. If it has to be cryogenic, for example, right? That energy is going to be lost to that. But this shows just from a, how much do I have to carry and how big is my tank perspective, right? It's some of these fuels look to be better than others, but there's little that's as good as diesel, if you will, admittedly. So next slide. So this is just another same type of story. This is I took from MAN, their perspective on it, and about the middle column there shows like the fuel tank size relative to, this is marine gas oil, but kind of similar for diesel fuel, right? And you can see that these various fuels, whether it's ammonia, methanol, LPG, LNG, right, that you've got to have more volume to carry the same amount of energy around. So that's kind of the main point here. So, but some of these fuels you can see on the far right, there's going to be reductions inherent to the use of those fuels. Some of them just inherently generate less NOx or PM when burned, which is a good thing. Next slide.
Hi, Vince. I just wanted to let you know that we've got 5 minutes left.
Yeah, I see. I'm trying to finish in 20 seconds, but it's really close. Yeah.
We're gonna give you 5 minutes.
Yeah. So okay, this is another perspective on the fuels. This is again from this DNV study, but the thing to look for here is the legacy fuel is kind of hatched out, and then the colors to the right for each of the optional fuels show kind of relative merit compared to diesel, and every one of these has some pros, but they also have some cons. So it's hard to find like the perfect diesel replacement. Next slide. This is another version, and again, Jeff Reed's on the call that put this together. But again, right, we've got different potential alternative fuels, and you know, again, compared to like if one of these had all green, you'd say, oh, right, no brainer, that's what we're going to do. But they don't, right? Every one of them's got some kind of downside. And this is strictly from safety and health and environmental perspectives. Next slide. Yeah, so I kind of have mentioned this, right? There's some challenges with these alternative fuels, but it's an area of active development. So definitely there's trade-offs, and talking to people about, you know, are we going to put ammonia on a public dock, and is hydrogen, you know, can we really do that? So anyway, again, the message is not, there's not some silver bullet really. Next slide. Yeah, so then from a combustion viewpoint, I kind of alluded to this, right? These molecules behave much differently than regular diesel, so there has to be modifications made to the combustion systems. That has to be accounted for. Next slide. But there are engine companies that are making these, right? So Wärtsilä is a good example for methanol, right? They have a IMO Tier 3 approved engine for methanol. Wärtsilä also offers a specific storage and supply system for methanol. All right, so this is commercially available. MAN Energy Solutions also offers a dual fuel unit. These are very new, right? But they're coming, right? They're available. Next slide. This just shows some details of a dual fuel injector, again, speaking to a need to evolve the combustion technology. Next slide. This is same kind of thing for ammonia, right? This is becoming an interesting fuel to consider. Again, Wärtsilä now has a commercial engine available as of November of 2023. It's not a Tier 4 engine, but it is Tier 3 compliant. MAN is working on these, and so is a company called WinGD. So that picture on the lower right, that's the SCR system for the MAN MAN engine. Active development with some commercial availability. Next slide. Again, this is just a bullet list of considerations for the combustion technology, if you will, with ammonia. A lot of questions, a lot of things to work on for this to be viable. Next. Okay, so yeah, quickly summarizing, we've got Tier 4 engines available. Their numbers are increasing. There's recent growth in the sub 600 kilowatt engine, which I think bodes well. Retrofitting the DPF, well, you know, if you've got the Tier 4 engine with the SCR, whether that DPF is going to work or not is basically a case-by-case evaluation of the vessel and the space. There's a lot of questions on regeneration and temperatures. If you can put the DPF closer to the engine, you'll use less diesel fuel for regeneration. All right, but this is an area of active consideration. Next and last. So alternatives to DPFs, not commercial yet. And as far as alternative fuels, lots of options are being worked on, but you know, at this point, there's no obvious best choice. But engine OEMs are working on these. So, and with that, I'll stop. So.
Great. Thank you so much, Vince. At this point, we are going to open things up for Q&A. We're going to extend for another 5 minutes into our break period, so we'll have a 5-minute break. So if you're an attendee, you can use the raise hand function to offer a question verbally. If you do offer a question verbally, please identify your name and affiliation for us before you do so, that we can know who's asking the question and know a little bit more about you. So I don't see any hands up, so we'll start with some of the questions that were offered in the Q&A box. We have a question from Eric Boone. Do you have the pricing as part of the data set? For example, what's the cost, what's the bill of materials, expected integration, and shipyard costs?
Yeah, so that'll be case by case. I will point to a study by the California Maritime Academy that looked at a number of specific vessels and kind of what is the installation and retrofit costs. Their numbers were generally $500,000 to $1.5 million for kind of the smaller boats, but again, it's case by case, right? Some of the larger ferries were, approaching 7 million. Those are 2019 numbers, so they've probably gone up a bit since then.
Great, thanks, Vince. We have another question in the Q&A box from Abby. With the Tier 4 diesel emissions control systems, how much of a fuel efficiency penalty is there? And how much does that matter given consumption rates?
Yeah, it's a very good question. I do not have a good strong answer on that. Andrew may from CARB, but I don't know that number.
And again, for any of our attendees in the webinar, you can use the raised hand function to ask a question verbally. And Andrew, I see that you came on video. Do you want to add anything to that answer?
Sure, I can add a little bit, but it would be best to consult
I can't hear you, so you might have the mute original audio issue as well.
Can you hear me now? Can you hear me now?
Yeah.
All right, thank you. Yeah, I was going to say it would be best to consult your applicable engine OEM, but there could be a slight fuel penalty going to Tier 4. However, any electronic engine would be much more fuel efficient than an older unregulated mechanical engine. So there's typically a 10% fuel efficiency increase going from a mechanical unregulated engine to, say, a Tier 1. So it really depends on what you're starting from and then what engine you're going to. So it's probably best to consult your engine OEM.
Great, thanks for the additional context there, Andrew.
Sure.
Another question here in the Q&A from Scott Smith. How is CARB addressing the concern over back pressure when installing a DPF? Is an amendment to the Commercial Harborcraft Amendment allowing for a bypass system forthcoming?
No amendment is forthcoming. So CARB is well aware of the exhaust back pressure issue. So CARB has worked with the United States Coast Guard Marine Safety Center throughout the commercial harborcraft rulemaking over the past 5 years. And so the Coast Guard Marine Safety Center's current policy on the DPFs is that they're just like any other component in the vessel exhaust system, which is a critical vessel system because it's related to propulsion. So the DPF would be treated like any other component, meaning that it would need to be installed according to the applicable subchapter design standards in 46 Code of Federal Regulations. Additionally, CARB's verification procedure has an engine pre-installation compatibility assessment that needs to be completed before any CARB verified DPF could be installed on a particular engine family to ensure that it's compatible with that engine family and that the DPF in its installed configuration will not exceed the applicable engine OEM's maximum allowable specification for back pressure. CARB CHC program is also currently actively working with the United States Coast Guard District 11 headquarters officers regarding a operational protocol for allowing a carb verified DPF system to utilize a bypass if necessary. And so this will be incorporated into the executive orders that will be issued for carb verified level 3 DPFs. And this would include operating protocols and reporting protocols for how the bypass is operated.
Great.
So
I think we've got 3 more questions in the Q&A and about 3 minutes. We're going to launch a poll here before we go to break. So our next question is from Richard Patch. Particularly with respect to smaller engines, 600 kilowatt and below, are any DPFS carb verified and commercially available?
There are no level 3 DPFs that are currently commercially available that are carb verified. There's currently a level 2 device, which would remove approximately 50% of the diesel particulate matter. But as Vince mentioned in his presentation, CARB's level 3 verification needs to, the device needs to be able to remove 85% or better of the diesel particulate matter. There's currently 3 technology vendors that are pursuing CARB verification at this time. The CARB verification process is fairly rigorous. It takes some time. There's a number of rounds of emissions testing, as well as a 1,000-hour durability demonstration requirement of in-use operation. So DPF should be forthcoming, but none are commercially available at this time.
We have a question from Paul Rangel. Is there a CARB-approved list of DPFs for CHC applications?
Andrew?
Yeah, sure. So CARB doesn't approve DPFs. CARB would verify the performance of the DPFs. And there is a CARB verification regulation. There's a verification program and a team at CARB. It's the freight approval section that is implementing that program, and they do have a public-facing website with a list of verified devices that are in other sectors such as stationary or on-road.
I'll just add that I just dropped a link in the chat that is to the page where the verified products are listed or will be listed once verified.
Great, thanks, Tracy. We have a question from Alex Brody in the chat. This one might be for Vince. What are the weight penalties when adding after-treatment equipment?
Yeah, I have the relative volumes, but the weight I'm not exactly sure. I'll be sure to incorporate that into the report on that. Thank you for that question.
Yeah, I can give a little detail on that. So it really depends on the engine and the vessel you're trying to install the device in, and so how much room do you have in the vessel, and then it comes down to the engine rated power and the exhaust mass flow, and that's going to determine the size of the DPF device that would be needed to accommodate that exhaust mass flow without exceeding the applicable engine OEM's maximum specification for exhaust to back pressure, because United States Coast Guard will not certify an installation of any device that would exceed that back pressure. So that's kind of the critical number. So it really depends on the vessel, how much room you have to work with, your engine, your rated power, and your exhaust mass flow number. So it's really something that needs to be determined on a per case basis, and that could potentially vary from different DPF manufacturers as well, because some of them use different regeneration strategies, and their components might be sized differently and might have different weights associated with them.
Great. Andrew? All right, so as I mentioned at the beginning of the meeting, we have a poll that we would like everyone to respond to. It's just a way to get to know better who's in the room and learn more about all of you who are attending today. So I'm going to go ahead and launch that poll, and you should see it pop up on your screen. And then you can go ahead and respond. The questions are written in Spanish and in English. So I've just launched the poll, and please take the next minute to respond to those questions. We'd love to get to know more about all of you who are joining us here today. And then Andrew, while folks do that, we have one more question in the Q&A that I think that you can answer before we go to break. It's from Lena. CARB regulation states that a newly acquired marine engine on or after January 1st, 2023, less than 600 kilowatts, does not require to meet Tier 4 standards. This presentation appeared to state otherwise. Can you clarify?
Sure, I can clarify. So that understanding is incorrect. So it really depends on the type of scenario that you're involved in, but there's typically 4 different scenarios that could apply to you under the commercial hovercraft regulation. And so there's certain times that when an operator that's repowering their engines would be required to perform basically a market survey to determine if there's a cleaner engine that's commercially available that could work in the application. And if it is commercially available, then they would be required to upgrade from complying with the Tier 3 end-use performance standards that would ordinarily apply below 600 kilowatts. They would be required to comply with the more stringent Tier 4 end-use performance standards. And so typically this market survey would be required to be done at the time of a keel lane if it's a newly constructed vessel type of project, and if you're trying to do a repower according to your compliance timeline in subsection E12 for in-use vessels, then you would be required to do that market survey 12 months ahead of your applicable compliance deadline. It depends on what type of vessel you have. So it would be tables 16 through 19 in the amended regulation. There's also a couple of scenarios that could apply here too as well under subsection E8 if you're doing an emergency engine repower, like due to an equipment failure. So at that time, you would be required to do that market survey again to see if there's a cleaner engine.
Thanks, Andrew. All right, so I'm gonna go ahead and leave the poll up. We can go to the next slide. We're gonna take a little bit less than a 10-minute break, and why don't we all come back at 2:15. So I'll see you all back here at 2:15. I'm going to leave the poll up for anybody to continue answering those questions in the meantime. We'll see you all at 2:15. All right, welcome back, everybody. Hope you got a chance to stretch your legs, get some water. We'll go to the next slide here. Okay, so I'm going to hand it back over to our colleagues at UCI, and they're going to commence with session 2 of today's agenda, which is Zero Emission in Advanced Technology Projects Overview and Applications.
Hi, Julia, can you hear me?
And Michael, if you're speaking, I can't hear you. You might need to go to the interpretation globe at the bottom and click mute original audio.
How's that?
Perfect. Can hear you now.
Thanks. I was clicking on that, but that wasn't, I needed to click on the English. Anyway, thank you very much, Julia, for that. Very glad to be able to present today. I'm going to be covering the current commercial operational readiness and challenges with zero emission and advanced technology commercial hovercraft. The way we went about this survey was to conduct essentially a detailed literature review, scientific journal articles, industry reports, government reports, media reports. But we also had, I think, 7 or 8 interviews with various stakeholders in the space, port authorities, vessel owner operators, vessel builders. So what I'll present today is sort of a synthesis of that. I also want to say before I start, this is a really important opportunity for us to get your feedback. Commercial hovercraft is an incredibly diverse sector with many, many different vessel types and vocations and things. So this is a great opportunity for us to get feedback on anything we might have missed or anything that needs to be included in our report. Next slide. So the CARB regulations specifically related to ZEAT, which is zero emission advanced technology, target short run ferries, which will be required to be fully zero emission by the end of 2025, and new and newly acquired excursion vessels after essentially beginning in 2025 will be required to operate with a minimum of 30% zero emission. Very quickly, the definitions for this is a pretty diverse potential and technological makeup, but zero emission refers to propulsion or auxiliary systems that generate no tailpipe emissions. Practically, that means fully battery electric vessels and hydrogen fuel cell electric vessels. Zero emission capable hybrid vessels are hovercraft with 2 or more onboard power sources, one of which is zero emission and one of which is not, like a diesel genset. But overall, the vessel needs to operate on 30% zero emission mode averaged over the calendar year. So practically that's a plug-in hybrid, either a battery electric with a diesel engine or a hydrogen fuel cell with a diesel engine as well. And of course, infrastructure is anything needed to support those propulsion methods or auxiliary methods, charging equipment, hydrogen refueling, et cetera. So that's what we're going to focus on: plug-in hybrids, full battery electrics, and hydrogen fuel cell vessels. One thing to note is that diesel electric hybrid tugs have been in operation in California for years, but they do not receive their electricity from shore power, right? The diesel engine charges the battery as the vessel operates, so they can't meet that 30% threshold, so they're not considered in this. Next slide. So globally, there is momentum for ZEAT vessels in the hovercraft space, although the largest markets are in Europe, and there's activity in Asia and also in South America. I'm showing here just some statistics from an IMO database. It's not necessarily comprehensive, but it does make the point. If you look at the left, that's battery electric vessel projects. There are more battery electric projects than there are fuel cell projects on the right. That's just largely a product of batteries being more commercially advanced and more cost effective currently than fuel cells. Although fuel cells are progressing, and I think we'll catch up. The other thing to note is that you can see the vocations where the most work is being done: offshore support vessels for transporting crew and supplies to things like oil rigs or wind farms or wind turbines, ferries and tugs for reasons we'll talk about in a few slides here. Next slide. So for the fuels that we considered or could be used in ZEAT vessels, of course, we have batteries and electricity. Hydrogen is what you feed the fuel cells. And then you see methanol and ammonia here. The reason I have these is not because they're being combusted, but rather they can be energy carriers for hydrogen. So they can be reformed into hydrogen, which then goes into the fuel cell. So that's a ZEAT fuel. And the point is with this slide, it's very dense. I don't want anyone to try to read this. The point is that each one of these fuels has strengths and it has weaknesses. And those strengths and weaknesses have to be considered as you're designing your vessel or considering the use of the fuel for the vessel. So for example, batteries, as I mentioned, they're more mature, cost-effective, potentially less safety concerns. It's not necessarily enough, but there is some existing infrastructure, at least at most dockside locations, that you could start from. On the other hand, they're heavy. They have range limitations potentially because of the energy density concerns. The charging times can be longer, right? On the other hand, hydrogen has a lot of flexibility with how it can be stored, produced, et cetera. Potentially, fuel cells could give you a faster response and higher power output. You could have longer ranges and quicker refueling times. On the other hand, there's safety concerns, both real and perceived. There's a lack of current infrastructure for hydrogen. There's uncertainty with cost, et cetera. So I'm just giving some high-level overview. These are the types of things we'll have more detail on in our report. Next slide. So one of the main focus was just to summarize or survey the existing projects in California for ZEAT vessels, and that's what I'll do in this section. Next slide. So short-run ferries. The ferries in general, some ferries make sense for ZEAT because they operate on fixed routes. They have loading, unloading times at each point that could potentially be used for refueling or charging. So they're somewhat favorable for ZEAT, some ferry routes. Of course, there are other ferry routes that are very challenging for ZEAT. Any that require higher power requirements or longer, for example. And one of the themes that, or points that I'll make throughout this entire presentation is that you cannot look at a vocational level when you're talking about feasibility of ZEAT. You have to look at the individual vessel individual operating location when you're making those types of determinations. So one of the main projects or first projects with short-run ferries is the Angel Island ferry conversion. They have 2 short-run ferries and an excursion vessel. The first that they're looking to convert or retrofit is the Angel Island ferry. This is a good opportunity for electrification because it's a barge type vessel, so the weight for batteries won't be as much of a concern. They're working with, I think, Green Yachts and PG&E with help for the infrastructure. It's been awarded grant funding. Another short-run ferry that's working on this is Balboa Island. They operate 3 wooden ferries, I believe. And they've been awarded funding through CARB. I think they're still at the stage of evaluating the cost effectiveness for their business model of converting to all electric. So these are just 2 examples. Next slide. Moving towards high-speed catamaran ferries, the Water Emergency Transportation Authority operates a fleet of ferries. Vince mentioned that. And they have developed a blueprint outlining conversion of at least some of their fleet to ZEAT in the next 5, 10, 15 years. I think it's a really nicely done document. The study has a lot of detail on the types of considerations and challenges and steps that you need to take when you're considering something like this. So they have this phased approach. I'm showing the top figure, a phase 1, a phase 2, a phase 3 for their short to medium routes. And you can see the color coding. Some are feasible with current vessel technology. Some are feasible, but will require operational changes. And then others are feasible, but will really need to change how they're operated from today. They've partnered with Wärtsilä to develop 5 battery electric fast ferries in this first phase. And then they also did a detailed look at the infrastructure that would be needed at their terminals. And looking at what they concluded is that DC fast charging is going to be needed. Another thing that's really important is battery energy storage is going to be needed, essentially to support the DC fast charging and mitigate some of those large power requirements on the grid. And it's the same sort of phased approach where some of the terminals will require minimal upgrades while others will require substantial work. Next slide. Another example of a catamaran ferry project is the Sea Change. This is a project that's been going on for several years. It's essentially a proof of concept of a hydrogen fuel cell ferry. It's a 70-foot aluminum catamaran with a top speed of 15 knots. It's currently undergoing sea trials for WETA with Blue and Gold. They have a short run route that they're doing. The current hydrogen refueling process is interesting. Again, this is sort of a proof of concept or first of its kind. So these things are being worked out, but they have a strict set of protocols that have to be in line with the port authorities and the fire marshal and the city of San Francisco, et cetera. So an example of how these sort of first projects have to work through a lot of the initial challenges as we do things here for the first time. Next slide. So tugboats are an interesting opportunity. You saw from my earlier slide that there is a lot of ZEAT tugboat projects. That's because some tugboats have operational profiles that could be conducive to ZEAT. Things like downtime, fixed routes, return to home base. They might have low power requirements for most of their duty cycle, followed by very short bursts of very high power while they're doing ship assists and these things. But there are also tugboats where ZEAT will be very, very challenging. So there's this wide range of tugboat operational profiles. So for some tugboats, it will be very difficult to transition to ZEAT. For some, it's a very competitive business. Some operate on month-to-month charters and may have to move locations frequently, which is very challenging for ZEAT because you need to be near your infrastructure that you've developed, et cetera. So again, the point being some individual tugboat in California may be feasible for ZEAT. And one example of this, a really nice example, is the E-Wolf in the Port of San Diego that was developed by Crowley. One of the reasons why this makes a lot of sense is that its activity pattern essentially is activity in the morning, followed by some downtime, and then some activity in the evening. So you're given this nice opportunity to charge during the day and at night. That being said, the charging infrastructure has been a problem or a challenge. They're working to establish a DC solar battery microgrid facility to support the fast charging. Again, the battery systems are really important when you're doing that fast charging, so you can reduce peak loads, and that's what they're doing. But that has been a significant challenge for them. And as far as I know, it's not up and running quite yet. Next slide. There are also several planned projects in California. One of those is at the Port of LA with a plug-in hybrid electric ship assist tug. There is funding in place for that. The assessment of that is that with strategic charging stations and careful operation, you could potentially be up to 90% all electric, which would be really nice from an environmental standpoint. There's also a planned tug that was just recently funded at the Port of Oakland, which will be supported by a microgrid power system. And then there was also the ZEAT project, which developed a hydrogen fuel cell electric ship assist tug. This was just a design. As far as I know, there hasn't been any actual steps towards construction. But it was an interesting design and an example of a hydrogen fuel cell technology. Next slide. So excursion vessels share some characteristics somewhat with ferries, that with fixed routes, potentially unloading, loading times where charging could take place. But similarly, there's a lot of variability in excursion vessels. Those vessels that have longer routes or quicker turnaround times or make many trips in a day will have a harder time transitioning to ZEAT. One example of a ZEAT vessel in California is the Enhydra, which has actually been in operation for several years. It's a very cool vessel, but it doesn't have optimal shoreside infrastructure to support its operation. So it's not maximizing its zero emission capabilities, right? So another good example of how important infrastructure is when you're designing these vessels. There are also some planned projects which were recently awarded funding. The Port of LA was given funding for the design and construction and demonstration of 2 battery electric hybrid excursion vessels. I think those are going to be operated by the Harbor Breeze. And then the Monterey Air Resources Board is leading a project to develop the first plug-in hybrid electric whale watching boat based out of Moss Landing. Next slide. So we looked at fishing vessels. That includes both commercial fishing vessels and then commercial passenger fishing vessels. This is one of the really challenging vocations for ZEAT. They have significant design constraints in terms of requiring, they're generally smaller, and they need things like live wells and space for their gear, and they typically operate potentially with high power or transit for multiple days, some of them. So it's a tough vocation for ZEAT. There are some opportunities for zero emission projects it's somewhat niche, but there's small nearshore coastal operations. I'll talk a little bit more about that in the US and world examples in the next section. So potentially the smaller vessels with very low power and energy needs could potentially do zero emissions. So things like lobster boats, which is what I'll talk about. It may be more feasible to do hydrogen fuel cell vessels because they have extended ranges and refueling times, but even that will be challenging. The one project that I'm aware of, and it's a really interesting project that just was awarded funding, was the conversion electrification of a commercial fishing boat called the Gold Rush. And other than the funding announcement, I have not been able to find any more information on that project. I think Green Yachts is involved. So it'd be great to hear more about that. That's going to be a very interesting and important project, I think, given that there isn't as much momentum in this space and it has a lot more challenges. Next slide. So dredges, another sector with just a tremendous range of different vessel types. Essentially, they're made to move sediment, but they vary from very small to very large, and they have all kinds of different equipment. So 2 of the interesting examples in California in terms of ZEAT. One is the Sandpiper, which is an all-electric cutter head suction dredge. It's used for harbor maintenance in Santa Barbara year-round. It's a smaller dredge, but it's able to operate with shore power. So a trailing electrical cable is provided. So it's full zero emission. So that's the kind of interesting project that might be applicable to other smaller harbors that need to do maintenance. Of course, there needs to be proximity to infrastructure so that you can run a trailing cable, for example. But it is a very interesting example of ZEAT from a dredge. The other dredge I'll mention is a much larger example built by Curtin Maritime, the DB Avalon, which is a hybrid clamshell dredge. It's 250 feet, so it's much larger. It has Tier 4 diesel gensets and a large battery system. The battery system lets it do regen while it's decelerating the bucket, which is interesting. It provides a lot. That's an efficiency benefit there. The reason I'm including it in my presentation is it according to Curtin, it does have the capability to connect to shore power. So it could potentially be zero emission operation. But the way these are used, for example, this one's currently being used at the Houston Ship Channel in the expansion. I don't know how feasible it would be to be connected to shore power, how often it could be. But nonetheless, it's an interesting dredge, and so I wanted to include it in this presentation. Next slide. Okay, so this slide I have combined pilot, crew, workboats, and just to be very clear, these are not the same. They're very different. Huge range of uses and sizes and engine sizes and et cetera. Mostly I'm including them on the same slide for timing's sake. But they can range from 30 feet to 200 feet, but on the smaller end, they could overlap with some of the smaller, faster boats. The example that I have for California is from Zero Emission Industries. It's the only one I'm aware of. They're working on a 27-foot fast hydrogen fuel cell vessel. According to ZEI, with their initial sea trials, they were able to get it up to 40 knots. So this might be a zero emission example that could be used for things like pilot vessels, crew boats, harbor patrol, this type of thing. But again, these vessels could be 200 feet and have equipment on them, or they could be a small boat that just transports crew somewhere. So there's a tremendous range of duty cycles and operational profiles and feasibility. So again, this all has to be evaluated on a per case by case per vessel basis. And for example, looking at pilot boats, Professor McDonald Vince mentioned the San Francisco Bar Pilots Association boat that essentially runs 24/7, very high power. That would be a very difficult boat to convert to ZEAT, especially full zero emission. So on the other hand, there could be pilot boats in other locations that aren't used quite as frequently. Maybe that would be an opportunity for a ZEAT boat like this. But again, needs to be evaluated at a case-by-case basis. Next slide. There are also two examples of research vessels that are converting to ZEAT. One is the Scripps Gordon Sproul, which is going to convert to a hydrogen fuel cell diesel electric hybrid system, which is interesting. It has a hydrogen fuel cell and a diesel engine. It's a 125-foot vessel with various scientific equipment, can operate up to 12 knots. One of the things that was interesting about this is they did a feasibility study and looked at a lot of different configurations. They found the hydrogen fuel cell hybrid had better performance than a battery electric hybrid. On the other hand, they couldn't do full ZEAT with the hydrogen fuel cells, just largely due to the volumetric energy density of hydrogen. The vessel had certain missions that had to be met, and they could not meet that with full ZEAT. Additionally, the RV Resilience is a DOE research vessel that's going to be the first plug-in hybrid research vessel. This isn't necessarily a California example, but I just included it here because it was similar. This is a 50-foot vessel, and the battery system can allow this vessel to operate in zero emissions mode, potentially for over 4 hours. Next slide. So those are the California examples, and then this is by no means a comprehensive overview of every project in the US and world, but these are some relevant projects that I think are interesting and can be potentially extrapolated to some California examples. Next slide. So in terms of short run ferries, there's a short run ferry in Alabama called Gee's Bend, which has been in operation since I think 2019 or 2020. No, 2019, yeah. And it was retrofitted to full battery electric. And the thing to note is that it's a really good opportunity because one, it has a very short route, it has a very slow speed, and it has a 30-minute load unloading time, and it only makes 5 trips daily. So it's not that it was easy for them to retrofit it. It was still quite a challenge. Shoreside infrastructure was a challenge, but that's the type of operational profile that ZEAT vessels can definitely meet. So this is a successful example of a short run ferry that's been in service for a couple of years. Next slide. In terms of fishing vessels, I mentioned these lobster boats. In Canada, they are working on both. They have a hybrid electric lobster boat, and then they're working on full battery electric lobster boats. Again, a very small nearshore boats that don't have a lot of power and don't go too far away from the infrastructure. So that's really there's not a lot of examples of commercial fishing that I think currently could do full ZEAT, but that is one example. There is a plug-in hybrid electric boat called the Caroline that's been in operation in Norway since 2015. It's also a nearshore coastal boat. It pulls pots, and I think it does some long lining and gill nets. So again, it's not going very far. I don't think it has high power requirements. So another example of sort of picking an opportunity. There's another vessel in Norway. I'm not going to try to say that name. I'm not sure how to say that, but it's a 229-foot plug-in hydrogen fuel cell diesel electric hybrid fishing vessel that they're designing for long lining. And then in the US, there's a project looking to convert a 46-foot salmon trawler to plug-in hybrid in Alaska. That's a collaboration with the DOE. And one of the interesting, I think that a common activity pattern to a lot of these plug-in hybrid fishing boats is that they can use the diesel engines for full speed, right? So when they're transiting to the fishing grounds, for example, they can use the diesel engines. And then once they get there, they can switch over to the battery electrics while they're actively fishing. Or another opportunity is when they're transitioning in and out of the harbor, they could use the battery electrics, which would reduce pollution impacts for populations in and near the marina. Next slide. In terms of excursion vessels, the Maid of the Mist in Niagara Falls is operating 2 different all-electric excursion vessels. I think they started operation in 2020, so it's been a few years. Again, another kind of good opportunity. The batteries are able to recharge in 7 minutes. The route is about a 20-minute tour. So that's conducive to battery electric. Next slide. So again, ZEAT tugboats. Some tugboats might make sense for ZEAT. Robert Allen has a line of hybrid electric tugboats. 3 of those are providing ship escort service in Canada. There's a couple examples of smaller all-electric tugs. So Damon has one. It's 82 feet with a 70-ton bollard pull. That's at the Port of Auckland and will be at the Port of Antwerp soon. And they just signed an agreement for the Middle East. Navtec Naval has the Z-Tug, for example, but these are smaller tugs. And so these full battery electric tugs, they might be feasible for smaller hybrid tugs in California, like line tender tugs, which help with mooring and these types of things. The hybrid electric tugs, like not like the E-Wolf. The E-Wolf is fully electric, but hybrid electric tugs can be feasible in some cases for ship assist and escort tugs, like the one that's being designed for the Port of LA. But again, there are certain tugs that are going to be difficult based off their operational profiles to convert. Next slide. Following, just emphasizing ferries for ZEAT ferries, Washington State Ferries has a plan to electrify their fleet. They're going to immediately convert 3 of their large RoPax ferries to hybrid electric, and they're also going to build 11 new hybrid electric ferries. They're also going to upgrade and install shoreside charging infrastructure at their 16 terminals. That's going to be a challenge because some of those are on smaller islands, for example. So the electrical grid there is going to need to undergo some important upgrades to support that. Globally, ferries, you saw on that chart, there's a lot of electric ferries or ZEAT ferries out there in operation, most in Europe, especially Norway. Canada has 6 hybrid electric car ferries in operation, and they're going to build more. 3 interesting examples from Norway that I just picked out of the 80. The first, I just wanted to note that the first battery electric ferry entered service in 2015. So they've been around now for almost 10 years. One of the interesting ones is the Medstrom, which is able to exceed 23 knots. So it's the first battery electric fast ferry. And then the MF Hydra is interesting because it's a fuel cell powered vessel using liquid hydrogen. So that's an interesting example of hydrogen fuel cells. Most of these ferries are generally medium-sized ferries that aren't fast ferries, but of course I note some examples here of outliers, but larger vessels are planned and being constructed, and so are smaller as well. So there is a range of different ZEAT ferries. Next slide. So there is an example of a ZEAT inland towboat, Kirby Inland Marine's the Green Diamond. And that's an interesting boat. They did have to change the design, including reduce fuel capacity and the size and configuration of the ballast, which could impact its capabilities. But it's still an interesting vessel. Maritime Partners Hydrogen 1 is another example that's slated for operation in 2024. That is an example of methanol, so it'll have onboard methanol to hydrogen reformation, which will be then put in a fuel cell. There are also global examples of ZEAT pusher tugs. Kotug International in the Netherlands has a line of battery electric pusher tugs. Robert Allen has designed 2 that are in service in Brazil. So there may be opportunities for ZEAT inland towboats in California, although a lot of California towboats are ocean-going ATBs, which are larger and have very high power requirements for longer routes and are very difficult to transition to ZEAT. But there may be opportunities, for example, for vessels servicing the ports of Stockton or the Port of Sacramento, more inland shipping, to consider vessels like these. Next slide. And then there's quite a few examples of ZEAT pilot crew workboats out there. Port Canaveral is working on an electric pilot boat. Damon has an electric workboat. Maritime retrofitted a 39-foot pilot vessel to all-electric operation, and Robert Allen has an all-electric pilot boat. Again, these vessels would struggle to do things like the San Francisco Bar Pilots Association's pilot boat, but there could be other opportunities, other pilot boats that aren't used as extensively, where these types of vessels may be applicable. Next slide. Okay, so moving to infrastructure. So this is charging, hydrogen refueling, for example, right? Next slide. So the current lack of infrastructure for both charging and hydrogen refueling, and the challenges with developing novel infrastructure, to me, and from what I've seen and talked to the stakeholders about, probably represents one of the largest challenges with expanding ZEAT vessels in California. And I have a section on challenges coming up, but I just want to note that here, that it's very difficult. What you need is based on a lot of different factors: the type and number of vessels, how you're using them, what's the characteristic of the infrastructure you have, how close are you to it, what are your peak demands, et cetera. This is not even a comprehensive overview, just a number of things you have to think about. As I mentioned, a lot of the vessel vocations are going to need to use DC fast charging, and they're going to need to get a lot of power. They're going to need to get a lot of energy onto their boat really quick, and that can stress the existing grid infrastructure, and it can also incur high demand charges, which economically could be a problem. So I think most situations where those are needed, I think they're considering a microgrid approach, right? So they're not just putting in chargers, they're putting in battery systems to buffer that, right? So the vessel can fast charge from the battery system, and then you can AC charge the battery during the rest of the time. Or also putting in solar PV is another example to manage this challenge, reduce your costs, provide reliability, resiliency, et cetera. On the other hand, a lot of these locations, these dockside locations or ports or marinas, harbors, are very space constrained, right? There's not a lot of available land. So to put in a microgrid could be very challenging. Next slide. There's also a lot of different ways you can charge your vessel. The slowest way is just using AC charging. It's simple, but it's slow. The DC fast charging I've mentioned a few times. There are systems out there. ABB and Siemens has them. There's more examples. But again, you really do need a short side battery most likely, or something like that to help manage it. Some interesting examples are in Europe. They have automated charging systems. So there's automated plug-in charging where there's like a robotic arm or these automated connectors, which the vessel pulls up and then those connect automatically. There's an ABB system in Europe that's being used in a Europe ferry project. And then similarly, there's inductive charging where there's pads on the vessel and the vessel docks and those pads contact and charge. Wärtsilä has a system using that. And then there's other potential strategies, which I haven't seen as much commercial momentum for, which is, for example, battery swapping. You can just charge batteries out for the ones that have been used, and then maybe mobile charging units. Just noting that multimodal infrastructure is going to be required for the incentives funding eligibility. And then the other thing that's important is standardization, equipment policy standards. This isn't just true for commercial hovercraft. This is true for anything that you're trying to electrify, trucks, off-road equipment. Standardization is really important. If there's a wide range of different plug types and standards, it gets very complicated. And that's especially important if there's any type of public or shared infrastructure where different vessels are using it. So there are companies working on this problem. Do I have 5 minutes, Julia? Okay, next. I better go really fast. So there's a lot of upgrades that may be required. You may need to upgrade your grid capacity, your wiring and cabling, switchgear. You might have to run conduit and trenching. All of that's very tough. You have to deal with regulatory hurdles, which is maybe the most challenging situation: permitting, inspections, environmental hazards. There are funding through these two different mechanisms that I have here in the bullets: core and the Advanced Technology Demonstration and Pilots Program for Infrastructure. Next slide. So as these owner operators or whoever's developing the infrastructure start to do it, they need to consider location. For example, if there's a terminal that's slated for an upgrade anyway, that might be a good opportunity to upgrade the ZEAT infrastructure there because it's more cost effective and simple to do it at the same time. You have to consider what grid power you have, what are your charging rates and times. Are you going to be able to work through the regulatory compliance with the utilities and the port authorities and the cities all together overlapping? Do you have operational protocols in place? Next slide. So talking about hydrogen, again, lack of current hydrogen infrastructure is a major barrier. I will note that California is working through this problem with on-road vehicles right now. So there is a precedent for establishing infrastructure. It hasn't been smooth or cheap but it is working, and there are stations out there. There are stringent requirements, safety and regulatory requirements. We're not sure yet how the hydrogen is going to be. Are we going to use liquid? Are we going to use gas? That requires different infrastructure. And it will require really innovative solutions. I'm just showing an example of ZEI's hydrogen case, which you can attach a gaseous source, and then you can attach anything to it to fill. So things like that are going to be needed. Next slide. Also, currently there's a lack of low-cost renewable hydrogen. The vast majority of our hydrogen is from SMR of natural gas, but there's a lot of momentum in California right now to produce an ecosystem that's able to provide a lot of clean, cost-effective hydrogen. One example is Arches, this figure on the right, which is a DOE-funded hydrogen hub. There's projects through that program at the ports of LA, Long Beach, and Oakland. Next slide. This is just an example of an interesting project that was going to be, I'm not sure how Hornblower's bankruptcy filing will impact this project. I hope it's still going forward, but it's a hydrogen barge providing renewable electricity. It's a really interesting project, and the type of example of a project that'll be needed. Next slide. All right, next slide. Wow, I'm way behind. So challenges for ZEAT. I've mentioned the regulatory hurdles. The requirements are fairly stringent, and more importantly, we're working through them for the first time, so they may not be fully established. The U.S. Coast Guard, obviously, their approval process, it's delayed some of the early projects, but again, they're supportive of it. It's just these are first-of-a-kind vessels. They have to do a case-by-case basis. It's a design review basis pathway. That process will probably get smoother as we move through and there's more experience. protocols established, et cetera, like potentially establishment of policy letters. Next slide. There's technological challenges with both the vessels and infrastructure. Marine environments can be really challenging. The environmental conditions, saltwater environment can be tough. The engines in a lot of CHC vocations are used heavily. So that can be tough for fuel cells, for example, to be operated that hard and for that long. There are a lot of marinized technologies and vessel components that are coming into the market. We'll have actually some of that in the report. Corvus, Wärtsilä, ABB, a lot of companies moving in the space, which will help with this. And one thing to note is that ocean-going vessel technology evolution may help dictate where CHC goes, because there's a lot of momentum for those large ocean-going vessels. And if all of a sudden ammonia or methanol bunkering becomes available, that might shape how CHC technology evolves as well. Next slide. Also, you have to deal with a lot of people when you do these projects, a lot of organizations, a lot of stakeholders, and it can be very complicated. You're dealing, one project could be dealing with the Coast Guard, the port authorities, regional local governments, neighboring tenants, et cetera. From our discussions with them, the coordination needs to begin early and often, especially with utilities for shoreside infrastructure. Also, workforce training will be needed. So we need to start training crews and captains who understand ZEAT vessels and developing training and operating manuals, for example. Next slide. Okay, so quickly wrapping this up. Next slide. So there are, from our review, there are technologically feasible opportunities for converting some commercial harbor craft in California to ZEAT in the near to midterm. I've mentioned a few of these. Again, these are just sort of general points, but the point I really want to emphasize is that assessment of these feasibility and deployment has to be made on a per vessel and per operational locational basis, right? You have to do a thorough and detailed assessment of the vessel design, its duty cycle, how it's used, what are the safety requirements, what's the workforce like, how do you maintain it? And then really important, you have to evaluate the opportunity around available or potentially feasible shoreside infrastructure scenarios, right? You can't understand if the vessel is going to work until you understand the shoreside infrastructure. So what we can't do is tell you this boat should be converted to ZEAT, because that's not what we did in our project. We did a survey at a higher general level. So then the next step for looking at this would be to identify specific vessels and do a far more detailed and thorough analysis of that individual vessel. Next slide. So one thing to note is that designing, constructing, and operating the infrastructure is essentially as complex or even more complex than building the vessel, and neither is easy. But in several cases, what we looked at, the vessel was out there and ready and operating, and the infrastructure wasn't there to support it, right? So there's this chicken and the egg kind of challenge where you need a vessel to justify the infrastructure, and you need the infrastructure to justify a vessel. At least the CHC owner operators that we talk to, and again, it could be slightly biased because we talked to the several that are involved in these early projects, but they all seem to be aware of and seriously considering ZEAT. But of course, there's hesitancy over concerns over the technological readiness, the infrastructure, the costs, and other challenges. I think for many CHC vocations, hybrid, so plug-in hybrids or fuel cell electric hybrids, will represent a more attractive option in the near to midterm until we have more experience and more advancement of full zero. So with that, I will wrap it up, and thank you very much. Look forward to your questions.
Great, thanks, Michael. Thanks for speeding up there, and if we have some extra time, we can.
Yeah, I'm sorry about that.
It's okay, don't worry. So it looks like we have 2 questions in the Q&A so far. We can go to the next slide as well. If you're an attendee, feel free to use the raise hand function, and you can offer a question verbally as well. We'll start with our first question in the Q&A, which is from Jacqueline Moore. Michael, you mentioned offshore wind support vessels. These aren't defined in the CHC rule. Does CARB consider them applicable to the rule? And I think either Andrew or Tracy are going to step in on that one.
Yeah, I agree.
Sure, I can answer that. So those vessels would be classified as an offshore supply vessel, which is a crew and supply vessel. So they would have applicability under the commercial harbor craft regulation. Sometimes these vessels are called OCS, which is outer continental shelf vessels. That's another name for them, but all of those would definitely have applicability under the commercial hovercraft regulation.
Our next question is from Zach Birmingham. Are there currently any amendments to codes being discussed that will make the implementation of shoreside ZEAT infrastructure easier?
That's a little bit outside the scope of CARB's regulatory authority, and so that's probably something that would fall in under the purview of California Energy Commission. And currently, CARB is coordinating with California Energy Commission on this, so that they are aware of the challenges, and they are developing solutions and pathways. I see that Bonnie has turned her camera on and unmuted herself, so I'll let her continue.
Yeah, I knew that was going to be a question that maybe took a couple of us to answer. CARB recognizes the importance of the infrastructure component. It's not like you can, for zero emission, you have to have both the plug and the socket, kind of both pieces. And so with that, we do have an infrastructure basically area that is all about infrastructure needs, infrastructure codes, across from anything from on-road, off-road. And so if there are discussions on how infrastructure can be streamlined at all sorts of different facilities, even, down to like apartment level to port level. So there are discussions across the board in terms of specifics for ports and marinas. I don't have any additional information there.
Yeah, I can maybe add a little bit to give a little bit of detail on what CARB has done on the incentive side, even though this is supposed to be more of a technology-focused discussion here. But the Advanced Technology Demonstration and Pilots Projects Program does have their Green Zones initiative. And so that program will provide funding for the shoreside infrastructure that could be required for some of these potential ZEAT projects. The core program, the Clean Off-Road Equipment program, also can pay for some infrastructure on the shore side, although that would have to be for a full zero emission project, not hybrid. So CARB is aware of these challenges, and CARB CHC program is working with a number of the different incentives programs. Also, Cara Moyer too. Cara Moyer is currently revising their commercial hovercraft, their marine guidelines, their funding guidelines to align better with the amended commercial hovercraft regulation. So CARB is working on the hovercraft side and trying to coordinate with California Energy Commission on the infrastructure side.
Thanks for the additional context there, Andrew.
Sure.
Mike, I do have a question for you regarding when the UCI report will be available to the public.
Yeah, that's a good question. I think we plan to submit our draft I think by July, end of July. So then it'll just need to go through CARB's review process. So actually, maybe Andrew should answer this one again, or Tracy.
Yeah, as Bonnie mentioned, the report is going to be become part of the report back to our board, which is due by the end of the year. So I think likely when we make that report available, that this will be made available alongside it.
Yeah. We do have a question from Abby. Michael, that was a fantastic presentation. It seems like new onshore facilities supporting offshore OCS wind development would be good locations for investing in charging infrastructure. Have you been involved in discussions with DOE or others on how to build that in?
So I agree with you. That would make sense. I wish I am not involved in any discussions that would be relevant to that, unfortunately. But I agree with your conclusion.
And we have a question from Ramin Ross. With ocean-going ATBs being included in the CHC rule, are there any examples of these vessels that currently are Tier 4 compliant?
So I didn't work on the combustion side. I do think there is one. I don't want to speak out of line. I think there is one example of a hybrid ATB, and I don't know that it could meet the demands of the California ATBs, but I think there's one in Europe. Maybe, I don't know if Vince is still on, but he might have a better answer for you on Tier 4 engines.
It looks like Mr. Graham Balch
Yeah.
is answering the question. So there is one Tier 4 ATB power tug operated by Kirby Corporation. So I believe the name of that vessel was Polar Cloud.
Yeah, so we have a comment from one of our panelists on the ZEAT panel later this afternoon, Graham Balch, who says that yes, the Cape Ann, we opacity tested it and it's
excuse me.
Thank you, Graham.
Okay, so we have a question from Alex Brody. Will shoreside infrastructure delays be considered for extensions on compliance?
Yes, we have a E1 extension that is for shore power and ZEAT infrastructure delays, and it's a 1-year extension that can be renewed one time, so 2 years total.
And we have another question in the Q&A from Ben Lilly about the UCI report, asking if a draft version will be made available for public comment before it's finalized.
I'll take that one. We have not discussed that. Typically, no. Under contract, we would be the reviewers of a report. There's ample opportunity once something's published, if there are things that you disagree with, to provide comments on, but we can discuss that internally and talk about that potentially at the next working group meeting. But typically, the way these contracts are developed is that we are the review function for the contractor.
Great, thanks, Bonnie. So Ben, it sounds like that's something that might be addressed in our third workshop in August. So stay tuned for more details on that. I don't see any hands up or any more questions in the Q&A. Really want to invite all of our participants here today to offer any comments or questions that they have regarding the commercial operational readiness and barriers to ZEAT commercial harbor craft, that content that Michael walked us through. You can use the raised hand function or use the Q&A. And Michael, while we wait, we do have 5 more minutes. So I know you kind of had to run through that last section. If there's anything else you wanted to elaborate on, while we see if any folks have any additional questions, you're certainly welcome to do that.
Thank you, Julia. I'll think that over.
Sure. And I'll just do another check. Oh, and we have another question in the Q&A from Eric Christensen. What happens in infrastructure issues? What happens if infrastructure issues are not resolved in a year?
The extension is renewable for an additional year.
I guess, Julie, I could talk a little bit more about hydrogen just quickly if there's any more questions, because I did rush through that slide. I don't know if that makes sense or if someone's raised their hand.
We have no other questions, so
yeah. So I mentioned very quickly that currently our hydrogen is almost all fossil, right? And that's from an environmental standpoint, that's not ideal. But California has significant momentum shifting to an ecosystem of renewable hydrogen. And I mentioned one, Arches, which is a huge effort. But I also wanted to mention that in the 2022 CARB scoping plan, which is a really important document, it outlines the plans for meeting our greenhouse gas emission goals. That was recognized that hydrogen was going to need to be a really important part, especially for hard to electrify sectors, which I think CHC certainly qualifies for. So the hydrogen that was being produced, in the scoping plan was things like renewable electrolysis, right? We can use our wind and our solar to split water. We can use our biomass and our biogas, renewable resources to produce hydrogen from that pathway. So as we do that more and more, it's going to get cheaper. The infrastructure is going to get built out. We may have things like pipelines, which will make it easier. So currently, hydrogen is infrastructure is a challenge. It's in its infancy, but I think moving forward that will change. So I'll just add that.
Great, thanks, Michael. All right, last call for questions. Okay, well, we have a scheduled break, so we're going to go ahead and take that break. We've got about, oh, we actually had another question come in. 2 questions come in. Michael, I don't know if you're up for another one. You did get a shout out. Q&A from TJ, enjoyed the overview, nice work.
Thank you.
We have a question from Alex Brody. Our routes are up to 100 miles without access to charging infrastructure. We will need to be 30% ZEAT. Battery weight will be up to 30% of the vessel's gross weight. Any suggestions?
I don't think I can do the math off the top of my head, but that's certainly the type of thing when you go to look at the feasibility of vessels that has to be considered, and that'll have to be estimated. We talked to a few builders, and the first thing they do is they come in with data loggers and software, and they plug it into their existing vessel that you're looking to either replace or retrofit, and they just take weeks and weeks of data, and then they go back and analyze it, and then they can come back and tell you, okay, here's what you can do. So, you know, for your specific example, I'm not sure exactly what math is going on, but you're right on that. That's the type of assessment that has to be done on a per vessel basis.
Great, thanks, Michael. And our last question from Abby Swain. You're probably aware of EPA's Clean Ports NOFO, which includes ZE technology track with $2.75 billion in IRA funding. And then she clarified, sorry, the NOFO closed Tuesday. Are you hoping / expecting to see any types of projects with Harborcraft that will help provide momentum?
Great question. We'll be hopefully the awards will be announced sooner rather than later, so we can get that into our report. But if it is announced before we get the report out, we'll absolutely put the results in.
Great, thanks, Michael. All right, and another shout out from Alex, thanking you for a great presentation.
Thank you, Alex.
Go ahead and go to the next slide, and we're going to take a 5-minute break. We will be back at 3:15. So go ahead and feel free to go off camera, stretch your legs. We'll be back in 5 minutes. All right, welcome back, everybody. We're going to continue on with our next agenda item, and we can go ahead and go to the next slide. I think we're just waiting on Lizzie to get back. But our next agenda item is our panel discussion for zero emission and advanced technology, ZEAT. And I'm pleased to present to our moderator, who will be Andrew Damiano with CARB, and our panelists, who will be Benjamin Ostroff, Christian Stark, Graham Balch, and Joe Burgard. And there we go. We can see them up on the screen there. So I'll hand it over to you, Andrew. I think we're going to begin with up to 5 minutes for each panelist to introduce themselves, and then we have a set of questions for each panelist. And just a reminder, this panel will go until 3:55, at which point we're going to open it up for Q&A.
All right, thank you, Julia. So session 3 here is intended to be a discussion with 4 commercial hovercraft ZEAT subject matter experts, including 2 California fleet operators, a naval architect, and a zero emissions systems integrator and consultant, who are all involved in a number of commercial hovercraft ZEAT projects throughout California. So gentlemen, please go ahead and introduce yourselves. You'll have roughly 5 minutes each, so please introduce yourselves and give a background of your company.
All right, well, I'll go first. I'm the general manager at AmNav Maritime. We're a ship assist company in San Francisco and LA Long Beach harbors. Like discussed earlier, we help the big ships in and out of port. We also escort the oil tankers, and then we do rescue tows as well. I've been in the industry for about 25 years, and this company's been around for about 35 years. So that's AmNav and what we do.
Well, I'm unmuted. I'll go next. This is Graham Balch. I'm the CEO of Green Yachts. Green Yachts specializes in marine electric propulsion systems. We help vessel operators with the entire vessel electrification process, from system design to Coast Guard certification, charging infrastructure, and installation of the electric propulsion system by our mechanics who have done more electric installations on boats than anybody in the world. We are an authorized dealer for CARB's core program for rebates on zero-emission equipment, and we sit on the committee revising the U.S. Coast Guard guidelines for the shipboard use of lithium-ion batteries.
All right. Thank you, Graham. Christian.
Hello, my name is Christian Stark, and we're the Roar Marine Design. We're a California-based naval architecture and marine engineering firm. We do a lot of work with all the government ferry operators in California, and have been deeply involved with almost every Tier 4 ferry application, and currently working on several battery electric ferry designs in the California market.
All right, thank you. And Joe. Oh, you're muted. Actually, no, you're not muted. You may be on the wrong audio, so you might have to go to that globe and select the English audio.
Joe, if you can, go to the interpretation globe, select English, and then also select mute original audio.
Still
nope.
muted.
So you're going to want to select listen in English. Oh, I think you just came on actually. Nope.
Nope.
Don't worry, it's a little tricky to navigate. So you're going to click on the globe and select listen in English, and then right under that, mute original audio.
Is this working?
Yeah, there we go. Yeah, we can hear you.
I'm sorry. It wasn't. I apologize to everyone. It wasn't the Zoom. It was my computer. I changed the microphone around.
No problem.
Yes, my name is Joe Burgard. I'm one of the managing directors here at the Red and White Fleet, and an owner here as well. Been with the Red and White Fleet for 25 years, and my background is in vessel operations and business management. I've been involved in a number of alternative fuel projects, as well as novel marine propulsion, being associated with zero emission industries, and then the build of the Enhydra. Red and White Fleet has been around since 1892, when Thomas Crowley, the senior, started rowing boats out to inbound ships. And so we've been on San Francisco Bay for a long time. We're still a family-owned and operated business, and we primarily provide sightseeing cruises on San Francisco Bay. We are also providing private ferry services and special events. And I think that's who I am and what Red and White Fleet is.
All right, thank you, Joe. So I have a number of questions prepared for you. So we'll start out here. The first question is directed at Benjamin Ostroff of AmNav. Ben, can you please provide additional details of AmNav's Bay Area Zero Emissions Tug, or BAY's Electra Tug project, including the ZEAT technologies and components AmNav is proposing to utilize in the vessel, and on the accompanying shoreside ZEAT microgrid charging system?
Yeah, sure, Andrew. Thank you for the question. We'll start on the shore side. It's a joint project with the Port of Oakland. They'll be bringing in a 1 megawatt line, and as we know, we're going to need a lot more than 1 megawatt. It's going to be about 6 megawatts a day. So, kind of building on what other people have discussed today, we're going to have a battery bank, a microgrid on the shore that is going to essentially store up the power and dump it to the boat when necessary. The duty cycle we accounted for was 3 to 4 jobs a day with 3 or 4 charging times, and one being a lengthy one to get it up to 100%. The vessel is an electric tug design that's already been implemented in Canada and a couple other countries. Robert Allen design. We're really super excited about it. What else can I tell you about it? We're really hoping to demonstrate that it's a viable option for all of us in the tugboat world and across all of the maritime aspects.
All right, thank you. So let's see, the second question is for Christian Stark of Aurora Marine Design. Christian, can you please outline the process Aurora Marine Design utilizes to determine if a particular vessel operation is feasible for ZEAT operation with commercially available technology and components? For example, vessel power requirements, route analysis, onboard energy storage requirements, and determining charging power required on the shore side.
All right, thank you, Andrew. It's one thing we've learned in this process of electrification is that it requires a detailed analysis of every single vessel and every route they intend to operate in order to figure out exactly what the power requirements are, since we've gone from diesel where we had huge margins to electricity where we're getting enough charge for one run plus a safety margin. So we've had to build out and ride vessels and come up with detailed load profiles for every and ensure we're aware of every route that we feel like we will be doing with that vessel, because the margins are that slim. Once we've figured out the energy requirements, we look at the turnaround time available on the route for charging, which also impacts the battery selection size on how quickly we can charge. And then whether the vessel can tolerate the weight. These are all extremely complicated analyses to look at, especially on the higher speed craft where weight gets to be critical. And then from there, if we pass all those margins, then we look at the shoreside infrastructure and what it's going to take on that route plan. Fortunately, for most of the ferry operations, we have a scheduled route profile, which makes it with some confidence we can figure out exactly what the energy requirements are per day. A little more challenging if you get into a non-scheduled service. And then from there, we go work with the shoreside utility grid providers to figure out what power is available, and then figure out what we need for buffering battery banks in the middle of that. And in the San Francisco ferry building area, where a lot of these ferry routes will be terminating, we've had to implement significant battery storage in order to buffer out the amount of power requirement from something like at peak implementation, which will take a while to get to, but power levels of 18 megawatts, bringing them down to the 10 to 12 megawatt range, which is still a significant amount of power, but you need to look at where those cost implications are and when you have to install new substations and when you don't, and how many batteries it takes to get you below those levels. So it's not an easy implementation, and it takes a lot of effort and detailed work between several sectors with the operators and the engineers and the shoreside infrastructure folks in order to determine whether it's viable for a vessel to go completely battery electric. And in general, I'll say the slower the vessel goes, the shorter the route, the easier. The longer, the faster, the harder it gets.
Yep. Thank you. That's a very detailed, informative answer. Let's see. So the next question is directed at Mr. Graham Balch of Green Yachts. Graham, can you please describe the commercial hovercraft ZEAT projects Green Yachts is currently working on, considering both the vessels and ZEAT technology utilized, shoreside charging infrastructure components, and negotiating rate structuring with local utility providers prior to beginning ZEAT projects?
Okay, there's a lot there. I'll give it a shot.
Yeah.
First, I want to thank Michael from UC Irvine. I thought that was a great overview of ZEAT implementation in the marine sector. I've seen a lot of presentations on marine electrification, and that was probably the best I've seen. So thanks, Michael. Um, Green Yachts is working on 13 commercial marine electrification projects, and the vessels are 3 excursion vessels, 5 short-run ferries, 1 fishing vessel, and 4 shuttle boats. In terms of the systems we're installing, that would be 4 full electric propulsion systems with no generator, 1 ZEAT system with an emergency generator limited to 20 hours of generator use a year. That's actually the vessel that Michael showed in his presentation, the Angel Island. 8 series hybrid, or what we call electric hybrid, because it is an electric system with a diesel generator added to augment range, because battery energy density is significantly lower than the energy density of diesel, as Vince pointed out in his presentation. One of these electric hybrid vessels is the fishing vessel Gold Rush that Michael mentioned. And beyond electrifying that vessel, we are teaming up with an acoustical ecologist to measure the sound environment pre and post conversion and confirming whether this reduces fish movement away from a vessel with an idling diesel engine, as past studies have shown. And then the last category, parallel hybrid, we're doing 0 of those. It's more of a diesel hybrid, which we call it because it's really a diesel engine with an electric motor for an EcoBoost. The majority that we're doing, again, is the series hybrid or the electric hybrids. It's where the generator can easily be replaced by future technology because it is a modular part of the system and not coupled to the shaft. Also, when the generator is used, it operates at full RPMs, meaning you don't have soot buildup from idling engines with DPFs and other emission controls. Lastly, only electric systems reduce greenhouse gases in addition to NOx. So if ZEAT hybrid is an option based on what Christian said about route analysis, it's a great way to go. In terms of the actual technology components, the electric motor itself is really proven and reliable. I've crossed the ocean on pure electric boats. Anyone installing an electric propulsion system today can be confident it will work and solve your power needs. Where the challenges lie and where technology is still developing is energy generation, energy storage, and charging. Energy storage is evolving rapidly today. For example, we are putting the first semi-solid state batteries on commercial vessels in the world in 2025. Onboard renewable energy generation probably won't replace the diesel generation for over a decade, unfortunately. I'd love to say otherwise, but that's where it is. And that brings us to the second part of your question, which is charging. And I think everybody who noted earlier that this is important and hard was spot on. I've heard that 9 of 10 planned marine electrification projects that get canceled is canceled due to the challenges with charging, and I believe that. If people listening today who want to install an electric system remember only one thing from what I'm saying here, it would be this: figure out your charging strategy before you start electrifying your vessel. Think about folks who've had a frustrating experience with an electric car. Most of the time, it's somebody who got an electric car before they installed a charging system at their home or apartment complex, and they had to run around trying to figure out where to charge their car. In the marine sector, I think it was noted earlier, there's a couple of vessels that are currently having some challenges because the charging refueling part wasn't in place. My advice, figure out your charging first. I think not just me, but from the others, I think that hopefully is a clear message. you asked about electricity rates. It's actually pretty easy in California. All Californians with solar or an electric car or an electric boat get put on a time of use rate plan and not a tiered rate plan. The Gee's Bend ferry that Michael mentioned has runaway electricity costs because they are on a tiered rate plan, meaning the more electricity they use, the higher rate they pay. And since they use a lot of electricity, they pay a lot.
Yeah.
In contrast, here in California, everyone I know with an electric car is paying $1,000 to $2,000 less a year in electricity than they paid for gas with a gas car, because they're on a time of use plan and program their cars to start charging after midnight when electricity rates are lower. We do the exact same thing on commercial vessels by programming the majority of charging to occur between midnight and 3 p.m. If you look specifically at the charging, for charging an electric commercial vessel, you kind of have two options. Very broadly speaking, when possible, and it's not in some cases, especially the type of boats that Christian works with, when possible, use existing infrastructure. Two 50-amp shore power cords can provide enough charge for many small and medium commercial vessels in California, such as fishing vessels, not to go full ZEAT, but to go ZEAT hybrid. This provides 21 kilowatt hours of charge, enough to charge a 300 kilowatt hour battery bank overnight. If you need more charging than that, the charging solutions will be hard. When we started our planning of the electrification of one of our clients, the Angel Island Tiburon Ferry, we quickly realized the local grid wasn't capable of supplying the electricity required for charging. PG&E estimated Angel Island Ferry would have to pay $500,000 to upgrade the grid and then pay for the electricity used. That was a shock when we heard that. However, PG&E suggested a really brilliant idea and worked hand in hand with Angel Island Ferry to implement it, which was to help Angel Island Ferry become a part of their EV fleet program, which allows PG&E to upgrade the grid without Angel Island Ferry paying for it. This was hard work because we had to get the charging equipment approved and figure out how to meet other requirements. But PG&E was fantastic, and Angel Island Ferry became the first marine sector participant in a commercial EV fleet program in the United States. Julia has put a link to the commercial fleet programs for PG&E, SDGE, and SCE in the chat for you guys. So you can click on those depending on where you are in California. In terms of the actual charging equipment, there are a lot of different technologies and strategies. We are excited to show everyone the charging strategy we are installing on some of the demonstration projects in California. It is incredibly simple to use, and over the past 4 years, has had a 99.9% uptime for a ferry system in Fredrikstad, Norway. But short of getting a NOR solution and all the technology options for charging, my advice would be follow the KISS principle. Keep it simple, first and foremost, in terms of how your staff will connect and use the charging system during daily operation. It's really important. And, I think that's the general first principle I'll end with. When planning any zero emission system, keep it simple. There's lots of talk out there about how advanced and cutting edge electric propulsion systems are. But what really matters at the end of the day is that it just works day in and day out. And so if you keep it simple, you'll succeed. That's hopefully helpful to everyone out there thinking about this.
That's a great answer. Thank you very much, Graham. Appreciate that. All right, so the final question is directed at Joe Biergard of Red and White Fleet. Joe, while ZEAT commercial harbor craft operational feasibility must be determined on a case-by-case basis, based on what you have learned to date with your ZEAT hybrid vessel operation, what are the commercial harbor craft vessel operational characteristics that Red and White Fleet has found to make a particular commercial harbor craft operation a good candidate for ZEAT applicability? Oh, I think you're muted again.
Can you hear me?
Yes, got you loud and clear.
This is a computer problem. I apologize. Something's up with my computer.
It happens. No worries.
Yeah. Yeah. Thank you. So I will speak specifically about my direct experience with the anhydra, and I can kind of give you a bit of an overview of how the system works efficiently for us, where and how it works in our application, and I'll also note some of the areas where there's challenges or the industry might consider, counter to what you're saying, like where it works and where there's specific challenges. And going through this, I'm going to probably touch on most of the things that have already been spoken about today. So forgive me if I'm oversimplifying, but in our specific application, our operating profile, where Christian said that he would start, and Mike McKinnon said, it's absolutely necessary to look at this. Our operating profile in the excursion site scene is such that it's not a constant mode profile. So we will move at like 80% of the standard power output in a conventional engine, and then we'll slow down and use 30% or less. There's lots of times and lots of variations. Because of that variation, when the hybrid system, when the loads are low, can go into the all electric mode. So that's results in us having about 50% of our let me see if I can phrase this correct. Our traction motor, or the motor connected to the shaft, is turning. Our generators are running about 50% of that time. So we're in EV mode about 50% due to the operating profile. So we get, directly from that, we get maintenance and service benefits. Our system is designed so that we have a variable speed generator. So the hybrid system is always in, I think, Graham, you had mentioned something about the generators operating at a high load level or most efficient. Ours is set up to run at variable speeds, but always at the max fuel efficiency of the generator. So depending on what that power load is, if it's in, say, 1200 RPMs or moderate power output, it might be at 60% load. If it's on the higher end, where higher loads are more tolerable by the engine, it might be at 70, 73. So when the generator is running, it's a lot more efficient. So in we have conventional vessels. Typically, they're powered for the maximum power demand. That might be really infrequent, and in our case, it is infrequent. The hybrid system, it's sort of built around what the average high power is, and then you use the hybrid system or the energy storage system batteries to supplement. If you have peak demands, it'll meet that. Another one of the benefits of our system is on our conventional vessels, we have 2 main propulsion engines and 2 generators. In this case, we only have 2 generators, so there's 2 less engines on board. These are typically smaller, and the auxiliary engines usually don't demand a lot of fuel, but I don't have them on this vessel, so I don't have to take care of them. I don't have to maintain them, and those are some of the areas that the technology works well in. If I still have a little bit of time, Andrew, I'll just mention a couple of things that they aren't like specific, but just areas.
Sure. Yeah, go ahead. I think we're doing pretty well on time today, so I think we have plenty of time here. Oh, we lost your audio again, Joe.
Can you hear me? Yep.
Yes.
Okay. Okay, I'll just carry on. So one thing that operators should consider with the hybrid system is the vessel has all the same systems that a conventional vessel has. It, all of the same plumbing and steering, and it even has conventional engines on it. Then it has a hybrid system. So there is added complexity to the system. As Graham is saying, you know, electric systems, electric motors, batteries, they are kind of low maintenance options, but they do take sophisticated software and management. So I wouldn't say that there's any specific drawback to that. It's just that there is a layer of complexity that comes with a hybrid system, where there's, I would name both a benefit and, you know, a potential risk with that. And the benefit is you get a lot more with a hybrid system. You get a lot more systems that are monitored. You get a lot more data, so you can really analyze the efficiency of your system. You're getting all kinds of data to analyze. And if there are problems, the ability to diagnose is, I think, higher than if it's just a conventional vessel. With that, though, comes the fact that with more alarms, it becomes a little bit more complex for the operators. They have to learn those alarms and understand what the system is telling them. And when the hybrid systems are operating with high voltage, so that can mean, as a precautionary reaction to like a potential alarm, is that a system will shut down rather than deregulate. So if you're in a conventional engine, you get a high coolant temperature, you'll get an alarm, you can draw back the engine. If it's just a loose pin in a system where there's a low voltage circuit issue, the system's going to fail safe and it will shut down that system. This isn't an insurmountable thing. It's just operators should consider this as they bring on a system, that there's a little bit of a training issue there. And then one of the challenges that we have is it's in getting the full benefit of charging from the shore charging. And as Graham is describing, you can get a certain amount of energy in overnight. But if that's insufficient amount of energy to your daily operations and how long you're at the dock, which Christian was talking about too, what are your turnaround times, what's the power demand, there is, it's not as simple as just saying, I'm going to get 30%.
Joe? Something weird's going on with your audio again. It was making
Yeah, try it again. It just stopped though.
Okay.
Yeah, it sounds fine now. It sounded like a robot for a minute, but it seems like it cleared up.
Yeah.
Sounded like a pinball machine.
Yeah.
Go ahead.
Yeah, I didn't say that about my background. I'm also part AI, so mostly artificial. Where was I in that conversation? I was just talking about the challenges with getting the full 30% as the regulations are written. Our vessel was built before the regulations were written. We didn't, design it around making sure that we could get 30%. But what I was trying to name was that there are challenges that goes back to the specific profile and access to shore power charging infrastructure, which has been touched on several times. So those were the topics I wanted to hit, Andrew. There's time for questions. I'll try to make my mic work.
Yeah. Thank you for that response. It was very detailed. So that was all the questions that I had for you guys. So I wanted to open it up and give our attendees a chance to ask some questions, either in the Q&A or perhaps verbally. It looks like we have some time to work with here.
Great. Yeah, so any of our attendees, please feel free to raise your hand, use the raise hand function, and you can ask a question of any of our panelists verbally, or feel free to put a question in the Q&A as well. And looks like we're kind of waiting for folks to formulate those questions. So for our panelists, if you guys have any questions for each other, maybe prompted by each other's presentations, feel free to also offer those while we wait for attendees to formulate their questions.
I'll jump in really quick if no one else minds. Listening to the three of you has been amazing. Thank you very much. I think there's a lot of synergies on San Francisco Bay and in California in general that we can all learn from each other and drive a more efficient maritime system in general. But the other thing I wanted to mention, that boat we're going to build it's just under 100 feet, and it's got 78 tons of bollard pull as designed. So good, powerful boat. And building off what some of you said, the operational profile is strange, kind of like Joe was saying. It's up and down. We don't get to we don't have the luxury of a point A to point B. So it is greatly challenging. The benefit to us is that the high loads are for short periods of time, where the majority of our time is spent transiting, which the batteries will easily do. So it's a really neat project.
So let me ask you a question, Ben. So is this vessel intended to work primarily in the Port of Oakland area, I guess Oakland estuary location?
Yes, sir. It's going to be at our dock at Pier 8, Berth 8 in Oakland.
Okay.
And work there for as long as they'll let me keep it for.
Yeah.
Yeah, and I saw you were kind of nodding your head a lot. It seems like you have a sense of agreement with what Ben was saying. Yeah, Joe? Nope, you might have to try again. The AI has taken over.
All right. Can you hear me?
Yeah, it's working now.
Sorry to have to do this so many times. My question for Graham was, and I know that you probably don't want to share a lot of specifics, but just curious if you use 21 kilowatt hours per hour, so it's relatively easy to get in 10 hours or whatever your downtime is. 200 to 300 kilowatt hours. So what is the what is the energy storage on the Angel Island projected at?
Sure. So that one has 686 kilowatt hours of semi-solid state batteries. And I think, if I remember correctly, we are doing 290 kVA from the utility grid, which still is below some of the public ferry levels. But the challenge with Angel Island Tiburon Ferry was that because they have a dock, we couldn't put battery weight on their fixed dock. And so weight for a DC to DC, battery to battery transfer wasn't an option. There's actually something really interesting we're doing on that project, which is, it sounds like a buzz term, but a microgrid, in that we are putting 91 kilowatts of solar on adjacent restaurants and using that solar to power the ferry. We're also tying that solar into some of the refrigerators in those restaurants. So that'll power the refrigerators as well as prevent food spoilage during a blackout. So it's a really nice collaboration. I don't think I exactly answered your question, but I think it's really important to think about the different ways that you can get your throughput from the grid down. One of those is having battery to battery transfer, but in our case, that wasn't an option for Angel Island Tiburon Ferry. Another is renewable energy, and the other is working with these companies and joining their commercial fleet programs so that they can upgrade the grid and create that higher kVA throughput to your facility without them having to charge you money on top of what's already a difficult project.
Interesting to hear about the solar power there. I wasn't aware of that aspect to that project. That's definitely multimodal. It's very creative. I like that.
Absolutely. And we do have a question through in the Q&A for Benjamin and Joe. This is from Peter Ellison with Ripos Inc. I hope I said that correctly, RIPOS Inc. And the question for Benjamin and Joe is, so with the compliance schedule outlined by CARB, how many or what percentage of your fleet will you be able to electrify to meet your deadlines? And will CARB grant extensions for this method of compliance? So we've got that first part for Benjamin and Joe, and then it looks like a question for CARB as well.
Okay, well, I'll start off for us. We are getting all our vessels that are not battery powered to Tier 4 status from the next few years. That's all scheduled out. And as far as the requirement for a full battery or ZEAT technology, there isn't one right now for the tugboat industry. The project we're doing is a demonstration to show that it's a viable option for tugboats and ship assist escort vessels.
Oh, lost your audio again, Joe.
So I think it's working.
Yeah.
So in Hydra, the architecture on board the vessel is such that the vessel could be converted to all electric just by upsizing the energy storage on board and batteries. The challenge with that, as we discussed, is really charging infrastructure, how big those batteries have to be, and how much power can get on in the windows, the turnaround time windows. Right now, I don't plan to do that on the vessel in the near term, say like 3 to 5 years. But I like that the vessel's designed and set up to easily make that transfer over. The other vessels that are potential candidates in our fleet are older vessels. And when I say older, I mean from like 1950, 1960. So making this kind of investment on an older vessel probably isn't the right solution. And there are some regulatory complexities with that because of the date of the construction of these vessels. They were built under different regulations, and this kind of conversion would pull them to modern day regulatory compliance needs, which they weren't built for. So they're probably not really under consideration, although if I could easily convert one, I would. And if I build a new boat, I'd happily build it as a hybrid electric boat. So I'm pleased with the way that the system works and how it works in our specific operational profile. So hopefully that's a sufficient answer.
Yeah. If I could,
oh, go ahead, Graham.
Reverb. Sorry, Christian. If I could jump in, the technical implementation of a ZEAT system is not that long or hard. I mean, yes, there are supply chain challenges because most of the systems are made in Europe, but it's really that the Coast Guard design approval process is much lengthier and harder. And I think in California, one of the challenges is that you kind of have to get your funding in order and then start the Coast Guard design approval, at least for small operators. Large operators might just be able to pay for it. But if there was a way for small operators to do the Coast Guard design approval with some funding in order to be able to get that part done and then applied for funding on, say, zero emission systems, that process could be really quick at that point. But I think, as CARB has evolved its regulatory policies, I think the next domino is its funding policies. And I think they're working on that. I think somehow getting the Coast Guard design process to be done would greatly accelerate the implementation of zero emission systems. It's the Coast Guard process that can take a long time.
I was just going to jump in there and just speak for a couple of the operators that I work for that the 2026 deadline, which is the only one that's coming up right now for full electrification on the short run ferries, is looking like we can get there, but I don't want to undersell how challenging it is going to be to get there with a lot of things to fall into place and a lot of things to get aligned. So we're hoping to get there, but it's possible it could fall short in some areas.
you all for providing a lot of additional context to that. We do have some questions in the Q&A for our panelists. We have a question from Graham. It's kind of a three-parter, so I'll put it in the chat for you as well. Are you expecting the electricity prices to go up as the electrification of harbor crafts advance? Considering your expertise, what are your thoughts on the necessary investments to meet the increased electricity needs? For instance, microgrids or substations? And have you done any analysis for repurposing batteries once they are done with their useful life?
All great questions. You know, I prefer my world of marine electrification, but I'll venture out onto the land side of things a little bit. You know, I think the important thing when thinking about powering a vessel is that the, you know, electricity in general costs less than diesel. And yes, rates are going up, but still the projected electrical rates is far lower, you know, than the cost of diesel for the amount of energy provided. I would say that in addition to that, it's really important to include renewable energy generation in your projects, because that is a way of making the energy free. Not, I mean, free is a strong word, but you know, having the sun power it. So anytime you can include solar on land and either a net metering back to the grid, so you get credits for it, or direct power, you know, just putting energy in the battery, it will reduce your cost. And I think a renewable energy generation could be a component of any marine electrification project in order to make it, you know, give you a competitive advantage in terms of your operating costs. And so you talked about an investment. That would be the investment I would suggest. The more you invest in renewable energy, the more you reduce your operating costs to operate. And then the last one about repurposing batteries, I think it's a really good question. It's actually one of the questions they ask when you apply to be a core authorized dealer. And I, because of that, went and looked for answers. And I will tell you, the answers I found were not good. Like, we got a quote on, you know, tens of thousands of dollars to recycle the batteries on some of the boats that we're doing. I don't think that's going to be the answer down the road at all. I think these batteries actually have value. I think that the batteries, after a 15-year life, still have some amount of energy capacity and could be used, say, for outside data warehouses or in virtual power stations. I would say that the answer on recycling large quantity of batteries has not been solved yet. I personally am not going to be the one on this panel solving that question. I'm going to leave that to Joe, Ben, or Christian. But I think it's a really important question that has not been solved. I think we have the technology to solve that problem. I think there's actually some US regulations that have gotten in the way, which is why I see Canada doing it. But an issue to address, I don't have an answer, but it's a really good question.
I can jump in here real quick. I would say for some of the larger operators, the current plan is to utilize the high power battery banks that will be going into the vessels eventually, when they are no longer usable for the vessels, to move into the shoreside buffering battery where weight is not critical, and use them as a second life. And then I understand there's third lives after that. So it's kicking it way down the road, and hopefully we have that that recycling plan sorted out by then, but we're hoping that's 20, 30 years down the road before they get done with their complete useful life.
Yep.
Yeah, we have another question in the chat that kind of furthers on this topic from Ben Lilly, who says that the use of secondhand batteries for shoreside buffer systems has been identified as a potential method for reducing equipment costs and weight. Taking used batteries off vessels after their state of health/capacity has decreased to a certain point, and using them shoreside where the lower capacity can be accommodated by less strict space constraints. Have any of the first generation electrification projects used this approach, or are there plans to incorporate this after the first round of battery replacements for any vessels? And a correction there that it should have read potential method for reducing equipment costs and waste, not weight.
Ben's right. I think you should go solve that problem.
Yeah, I would say, in Europe, obviously the first generation vessels happened a little while ago, and I'm not sure what their regulatory framework is over there. Here, you're looking at it. We're in the first generation implementation right now, so we are hopefully quite a ways away from having to deal with moving those to a second life.
Great. Any other input, Ben or Joe, on this topic?
And it's what we're going to do with the batteries in 15, 20 years. We found some batteries that have a 30-year life as well. And what we're going to do with them is being discussed, but no good answers have come forth yet.
Yeah. In the meantime, since we don't have an answer, although I thought what Christian said was very good as well, that not the data centers, like I said, but short side battery to battery charging. But I would say right now, since we are, as Christian said, in Gen 1 of the effort in the US versus Europe, I think the important thing is to treat the batteries right? Don't discharge them too much. Don't have your C rate, your discharge or your charge rate be too high, because that puts stress on the batteries. As long as you operate within parameters and you treat your batteries right, they will last a lot longer than if you don't. So that's not been the answer that you're looking for, but right now I'd say, not because we're trying to punt the can down the road, but because we want to have those batteries last as long as possible. Treat them right, and they will last longer for you.
Thank you. And Joe, just want to check and see if you had any input on this topic as well.
I'll try. Oh yeah, I can see that my mic's working. Yeah. I would just second what Christian was saying, is that we're in the first generation right now. I would make, I don't know if there's a valid observation, but the smaller operators are probably not positioned in where they could take, like, I don't really imagine me being able to be the one who's going to implement the second life on my equipment. A large, ferry operator that has many vessels and charging infrastructure, they might have the wherewithal and the plans to actually be the user of the second use. So there are people in the industry that look at the kind of battery chemistry that we have, its useful life, and I'm hoping to be able to move them to a second life, but I won't be the person doing it.
Like, this is a really prescient issue in this industry, and a space with a lot of opportunity for innovation and growth. We also had a question in the Q&A. Ben was kind enough to answer. Eric Boone asked, what company offers these batteries with a 30-year life? And Ben doesn't remember off the top of his head, but is gonna check on that. We have another question in the Q&A for you, Joe, from Abby. Joe, for those oldest vehicles that you don't want to repower for regulatory reasons, are you using biodiesel or any other cleaner than standard fuel?
Yeah, that's a good question. So the CARB regulations require that we use renewable diesel, which we've been using since 2018, so 5 years prior to the implementation of the rule. That has greatly reduced carbon index or footprint. I won't explain it all now. So yes, we do use those. Also, those vessels have been repowered several times. So they are either tier 3 or tier 2 because of their horsepower. They're a little bit lower. I will repower them to tier 4 if the tier 4 engines for their power are available by the regulatory compliance. So the older vessels will have to come into tier 3, 4 compliance if they're not already at tier 3. So that's the answer. And I would just mention too on the reuse of the batteries, the battery manufacturers, they're in the business of selling batteries, but the battery, like selling new batteries, but the folks that I speak to, they are the most knowledgeable about Second Life, and how that market is developing, and they actually use that, they're reclaiming some of their batteries and, as described, using them for shore infrastructure.
I don't see or hands up. We do have a few minutes left, so I'll throw it back to you, Andrew.
Yeah, I just wanted to take a minute to clarify some things, because it sounds like maybe not everybody in the audience is clear on the regulatory mandates for ZEAT. So the amended Harborcraft regulation has requirements for short-run ferries that begin after December 31st, 2025. So it'll be effective January 1st, 2026. That's the compliance deadline for ZEAT short-run ferries. The other vessel type that has a mandate is for newly constructed or newly acquired excursion vessels after December 31st, 2024. So that will be in effect on January 1st, 2025. There's a definition in the Harborcraft regulation for zero-emission capable hybrid. And in order to utilize any of the available ZEAT credits that one of these vessels could potentially generate, there's a 3-year ZEAT credit and a 7-year ZEAT credit. The 3-year ZEAT credit can be generated by a hybrid vessel that meets that definition in the regulation of a zero-emission capable hybrid, which means that it has to have 30% of its total annual vessel power come from a zero-emission tailpipe power source. The 7-year ZEAT credit is available for fleet operators that could potentially build and operate a full zero-emission vessel. And so these ZEAT credits could be utilized, by fleet operators to push out compliance deadlines for other diesel-powered vessels in their fleet. So that's basically how that works. That's a little bit of an overview of the requirements and the timelines, and that definition and that 30% power requirement that are in the reg. And that's about it for me. Does anyone else have any questions, the attendees? Anything in the Q&A, Julia?
No, I don't see anything. So
Okay.
I'll ask panelists, anything else that you want to offer? Graham, I don't want to put everybody on the spot, but Graham, that was helpful that you kind of synthesized one takeaway for folks to take home from this conversation about getting their ducks in a row in terms of setting up the charging before starting to electrify their vehicles. So I want to kind of give that opportunity to the other panelists. Don't feel on the spot either, but if there is kind of one takeaway that you want folks to take home, please feel free to offer that.
I guess the one takeaway from me and AmNav going through this process of getting this project started kind of closely aligns to what Graham is saying, is do your homework and plan. There's a lot of organizations involved in our project, from Cal Maritime to Working Waterfront to CARB, and it takes a lot of coordination. So plan ahead. The regulations are coming, and if you haven't started, do it as soon as you can.
I would say that if your operating profile is a good one for it, like the short run ferries, I think it's a great investment, particularly right now while there's public funding available. We built our vessel without any outside funding. I think it's going to work out fine over time. We'll get a return on that investment, and we're still in the infant stages of this technology in the marine application. So there's a lot of learning, but it's getting easier and easier, and the technology is getting more trial hours on it, and there's more industry knowledge. So I would say to those who are wary of it, don't over emphasize that trepidation, that there's lots of opportunities to make this technology work.
All right. Well, thank you very much. I really appreciate all of you taking the time to be here today and, you know, give us some insight into your projects and your companies and everything that you do and what you're working on.
You, Andrew, appreciate it.
Sure.
Great. Thank
all right,
you.
I'll hand it back over to you, Julia. Thank you.
Thank you to our panelists, and I think we'll get our last slide on the screen here and just cover some next steps before we adjourn for the day. All right, let me change my view here. Okay. All right, thank you everybody who attended. Want to cover some closing points with you. So our workshop number 3 is scheduled for August 2024, and we'll be sending out more updates in the following weeks. Additionally, if you have any other comments to submit, there's an email there on the screen, and I'm also dropping all of these links in the chat right now. So please feel free to send your comments there. If you have any questions specifically regarding the technical working group, you can reach out to Adriana Chavez, and her email is on the board there as well as in the chat. And for updates, you can also subscribe to the mailing list. And I just want to check and make sure there's nothing else in the Q&A, and I don't see anything. So that concludes our meeting for today. But I think, actually, excuse me, I wanted to hand it over to Babak, who I think had some closing comments that he may want to offer. So just want to check with you before we officially adjourn.
Sure. Can you guys hear me?
Yes.
Yes.
All right. Hi, good afternoon. I'm Babak Fazakifar. As Julia mentioned, I'm the manager of the Freight Technology section within CARB's Transportation and Type 6 division. The section is in charge of implementing CARB's commercial hovercraft regulation. Thank you all for joining us today for this informative technology assessment and zero-emission workshop. Special thanks to our presenters from UC Irvine for sharing their expertise, to Sac State for facilitating a great discussion, the panel members for their insightful contribution, and the CARB team and my staff for their hard work in putting this workshop together. We've covered a lot of ground today. I hope you found information valuable and gained some new insights. Thank you for staying with us until the end, and have a great day.
Thank you, Babak. That concludes our meeting for today.